Hi guys, welcome to my channel. Let us have a look at a physics paper just to get ourselves started on our revision to our prelim exams, and hopefully this may be useful also towards the finals. So we're just going to scratch the surface using this paper today, and I will post another video which is going to be a complete paper for a trial exam for Thursday, and we will hold our classes as well tonight at 7 p.m. as well as tomorrow still the same time. In between, look at these question papers, do practice alongside, and of course try any other similar questions. So this is from the EC June 2025 instructions. We need to read all of them, guys, but these are not to be taken lightly, as they have a direct impact on how a student scores marks in there. All right, so these are the trio that one needs to look for. And of course, folks, keeping in mind that when an explanation is required, any applicable phenomena may be used. Right, let's look at these MCQs. 1.1 reads, a box is placed on top of a truck while the truck is stationary. So these two mean, these two are stationary. When the truck starts to move, hear that, it starts to move, which one of the following statements will correctly describe the motion of the box? Obviously, the one that's moving is the truck, so the box will try to resist that motion. In fact, if one was to take a camera and just make this as slow as possible, perhaps place a marker right around there or something that marks the position of the end of that box. When this truck starts moving forward, because of inertia, this box will slide backwards so as to remain in the same position. You'll almost see that, of course, there will be some level of friction that may make this perhaps rather slow, but you will see that this box will almost not escape that position for a while until it is overcome, of course. So let's see. It will remain stationary, not necessarily, because the truck will be trying to move. It will essentially move in this direction to at least try to remain in this position, although it may not exactly be like that, but it will try to be as close to that as possible. It will move forward in the direction of the truck, not at the beginning. It will move backwards as the truck is moving forward, yes, at the very start of that truck's motion. It will move forward and then backwards. That's ridiculous. So this is the best answer for the situation given to us right now. Now, ball P and ball Q of the same mass are dropped from the same height. This is very important. Onto a concrete floor. Both balls hit the concrete floor at the same speed. Okay, V. Ball P rebounds with the same vertical speed. Can you see? If it rebounds with the same vertical speed, this is an elastic collision. All right? Why? Because we can see kinetic energy is conserved as the velocity does not change. But ball Q rebounds with speed half of V. So if this is the case, we are talking about an inelastic collision. You know, the power, guys, of always knowing things to as fine a detail as possible makes effortless very challenging situations. At the same time, even if there is a bit of an effort necessary, it doesn't become such a painful exercise. Right, so we have the sketch given to us, and We know that, okay? We've got an elastic collision with the floor, and we've got an inelastic collision with the floor. Right. So which one of the following statements regarding the collision of each ball with the concrete floor is correct? Kinetic energy is conserved for both balls P and Q. We can see that it's not both. Yes, P, but not Q. As a result, this option is wrong because it's partially correct and partially incorrect. The change in momentum of ball P is greater than that of ball Q. Well, that statement sounds right. The contact time with the floor is the same for both balls P and Q. Well, contact time is not the same because we will see that if it was to be the same, then we should have, the same velocities, either half of v or both v. But this one has lost energy, so that means the contact time must have been more than the other one. Right. Again, this is coming from knowing what is the change of momentum. So let's have a look and see. We know that the impulse momentum theorem is all at play here. We will see about this as well. We'll just see. Momentum is conserved for the collision of ball P, well, but not for that of ball Q. Remember, momentum is conserved irrespective, usually, in an isolated system, we say. And but kinetic energy may or may not. Now, this is what we need to think about and to think about correctly. What do we mean when we talk of an isolated system versus a closed system? I'm going to explain the difference just shortly. This question is actually jam-packed with some pearls that a student needs to know. Let's first explore option B. We were told that, the change in momentum, we know that basically change in momentum for ball P is going to be the mass times the final velocity minus the initial velocity, right? This is equal to the mass m. Final velocity is v, but now we need to choose a direction. So we may choose down as as positive. Then it means up is going to be negative. Remember, with momentum, we always need to choose a direction. So this final velocity is going to be minus v. So this is m into minus 2v. This is going to be minus 2mv, okay? That's the one. Okay, at this stage, we're looking at the magnitude because we're talking about great versus less. Remember the sign, momentum is a vector, so it talks about direction. So it doesn't mean it's an integer, where we can say minus 2 is perhaps smaller than a 0 or whatever. So this only speaks about direction only. It has no influence on magnitude per se. Please not. This is not about magnitude or size per se. Right, we need to remember that. Now let's explore the change in momentum for this Q. It's going to be mass times the final velocity minus the initial velocity. I really hate this kind of, annotation, or what you call. This notation really irritates me. I hate it, guys. I don't know why we cannot go back to the normal stuff. Final velocity, guys, should be represented by V. Initial velocity should be represented by U. This makes a very clean equation to write. This whole thing makes it a very busy and unnecessarily complicated stuff. It's unsightly, actually. Anyway, let's forget about my own preferences. At this stage, I'm just gonna do what I know how to do. But again, guys, whatever is acceptable, sometimes you can just do. I wonder what would happen if you just do the way I like using these. Anyway, we'll find out. Now, the final velocity here is minus half of v minus the initial, which was v. So this is m into, multiply 2 there, we add, so it's going to be minus 3 over 2 v. Right. And then we will see that we get minus 3 over 2 mv. Again, folks, we need to remember this is only about direction, not size. Okay, so basically the magnitude here is this. And the magnitude is that we can see, guys, 3 halves are certainly less than 2 because 2 has got 4 halves. So 2 is equal to 4 halves. Whereas this is just 3 halves. So we're missing 1 half. So in essence, the change in terms of magnitude, that of P is greater than that of Q. Do not be fooled by the signs. The signs only represent direction, not size. This is a real life situation. We're not dealing with these as integers, so to speak. Great stuff. So we accept this explanation. Now the contact time with the floor is suggesting another situation now. Okay, I'm thinking about it. It affects the magnitude of the resultant force. And remember, the resultant force has a direct impact on the acceleration. Now, one with the less acceleration will have the less velocity, and the one with the greater acceleration will have a greater velocity. So in essence, it means the issue here is relying on the resultant force. Now, the resultant force here is not going to be the same for the two, because this one will have a lesser velocity. The rebounding velocity is less, meaning it has less acceleration. So we can easily say safely acceleration of P is greater than the acceleration of Q after the collision. And if this is the case, it means the resultant force for P is greater than the resultant force for Q. And if this is the case, we know that it means the contact time for A must be less than for P is certainly less than the contact time for Q. Right. So as you can see, guys, if you understand how things work together, you will not be fooled, even though something may sound correct. So this is not correct. So in essence, our answer is B. Again, this is one of those questions that are not so easy to answer if you're not careful. Now let's talk about the conservation of momentum in this case. When do we say momentum is conserved? Momentum is conserved in a closed system, right? That is the case. So momentum is conserved in a closed system. That's what is important. Or an isolated system. Okay. Now you may ask a question, what is isolated versus closed systems? Because this often causes problems in not understanding what exactly is these two. Now remember, the isolated system, guys, there is no exchange of both matter and energy. So nothing can be exchanged in an isolated system. It's like everything belongs there and nothing else. But a closed system, there is no exchange of matter. Is it matter? No exchange of both matter and energy. But in a closed system, there is no exchange of matter, but that of energy. All right. Excuse, I don't know what that is doing. Don't do it. Okay, so in a closed system, energy can freely leave or enter. As we can see, momentum can be conserved in a closed system, but we know energy may not. This is when we're talking about collisions being elastic versus inelastic. But in a closed system, there can never be a situation where kinetic energy is somewhat lost in a way. So in an isolated system, both momentum and kinetic energy should be conserved. In fact, energy, mechanical energy, should be conserved. Whereas in a closed system, momentum may still be conserved, but not energy per se, as we see with the kinetic energy. Okay, guys, so that we need to think about. So at this point, momentum, whether this is isolated versus not isolated, closed versus isolated, because this is what suggests the idea here is that we've got perhaps, we've got perhaps P, we can say this, the situation of P would be what we would call an isolated system, versus Q, which we can say it's a closed system, but energy was lost. So in a way, that is a very gray definition or delineation of the two systems. So guys, please know, because sometimes with the definitions or the principles, it is a very important issue to think about what we are talking about. When we say momentum conservation, I would say to a student, rather avoid saying isolated system. Why? Because there may not be a conservation of energy as well, or mechanical energy. So a closed system, we know, can freely lose energy or gain energy, while matter cannot be exchanged with its surrounding. To say isolated system, that would automatically mean even energy is conserved at the same time, and that's not exactly the idea, is it? So again, folks, depends again on who teaches you and whether they are clear themselves about what's cooking here. So sometimes there's a bit of a fight between those two, but understand, an isolated system cannot exchange both matter and energy with its surrounding. It's almost like a perfect situation of some kind. Whereas a closed system may share energy, with its surrounding, but it may not share, matter. Take, for example, if you take a pot, you close it, and you put water in there, and then you put it on fire. That pot will gain energy, but the fire does not enter inside. And the water inside does not enter the fire outside, but they can exchange energy between the two. The heat from the fire will be transmitted into the water and vice versa. Okay, that makes sense, I hope. Right, that is a closed system as you can see, Le Chatelier's principle is on a closed system, usually, because energy can freely enter. That's why temperature can affect the equilibrium position. All right, okay, all right. But with elastic collisions, we're talking about isolated system. This is why when we talk about an elastic collision, it is literally an isolated system at that, should I say, in that scenario. But if it is not clearly stated that kinetic energy is conserved, it is best to consider that a closed system, because there may be a free exchange of energy with the surrounding. Anyway, guys, we have gone too much into the details, but again, whenever I find an opportunity to clarify certain things or to highlight certain things, I will do so, because it's not about just answering these questions per se, but it is to use these questions to prompt an explanation on some issues that may become a nightmare in the next exam if not well understood. Right, so that's it for that question. Our option is B. Now, 1.3 says a car of mass m travels along a straight road with a velocity of magnitude v. The driver sees the traffic lights turn red and immediately applies the brakes. The car stops uniformly in t seconds. You see, stops uniformly in t seconds from the moment that the brakes were applied. It means when the brakes were applied, they were maintained at a particular rate so that the deceleration or the acceleration thereof in the opposite direction was the same until the car stopped. The person did not continuously apply the brakes so much that the deceleration kept on increasing. When we say uniform, we mean it's constant acceleration. Right. Okay, which one of the following represents the magnitude, again we're looking for size, of the average force exerted on the car during the braking period of t seconds? All right. So guys, this is the question of Newton's laws of motion here. So we know that the resultant force is given by mass times acceleration. So this is equal to the mass is m. Acceleration is the change of velocity over time. So we know that it's going to be 0 minus the initial velocity divided by t, the time. Now this is going to be minus mv over t. Right. So again, we were looking at the magnitude. This only tells us about the direction of acceleration or resultant force. Direction of force and acceleration. All right. So we can see there's no question about it. So easy, standard grade question. A ball is projected vertically upwards, and we are to ignore the effects of air resistance. Now, which one of the following statements about the acceleration of the ball at its maximum height? We know that if we project a ball upwards, it's going to go, slow down, reach maximum height, come down. And when we ignore the effects of air resistance on the ball itself, there's only one force acting. The resultant force is Fg. And we know that Fg is itself equal to mg. And mg is the gravitational acceleration. So we know that the acceleration is going to be that of gravity. Right, so it's not 0, it's g, and it's always directed upwards. Downwards. So it is not all the others. So the option here is B. All right. So consider the statement below. Work is done on an object when a force displaces the object in the direction of force. Okay, that's true. Although not always the case, but that is true. Mechanical energy of a system is conserved when an external force does no work on the system. We know that, because the conservation of mechanical energy happens when there's no external influences from non-conservative forces. All right. Now, the work done on an object by a net force is equal to the kinetic energy of the object. Well, it's not necessarily just kinetic energy, but the change in kinetic energy. Okay? So it's the change in kinetic energy. Then that shows that there is a force at work. So this statement is not exactly true. So be very careful. These are very subtle differences with the reality or the truth of the principle. Now the question is, which one of the above statement or statements is or are true? We know that it's 1 and 2. So again, it's a standard grade question where if one does not understand the options, then it becomes a nightmare. Okay, if the net work done on a moving object is positive, then we can conclude that the kinetic energy of the object has not changed. Not true. Has increased? Yes. Has decreased? No. That's when it is negative. That is work done by friction, for example. It slows down an object. But if we're doing positive work, we will speed up. That's acceleration, meaning we're adding more resultant force. So it's not zero. So this is true. All right. Okay. Again, if you just want to think about it here algebraically, we know that work done is going to be equal to the change in kinetic energy. If we look at that, the change is mass times, we can say it's the half of m. When we factor this out, then we can say it's going to be the final velocity squared minus initial velocity squared. I am tired of these other things, guys. Let's just, you know what, just use a u here. But you will understand that the u stands for final velocity. I think we should go back to this, man. This is much clean, less confusing. All right. So now, guys, remember, we can only get a positive answer when the final velocity is greater than the initial velocity, because this difference, we can say this can only be positive when the final velocity is greater than the initial velocity. And remember, if final velocity has increased, then that means we have accelerated. Can you see? Right. And if we have accelerated, we know that definitely the last, or should we say the final kinetic energy will have increased from the initial. So that's how you think about it. So certain things, we just think about the equations and see what are the implications. And if we can understand those, because we cannot accelerate without a resultant force, right? We need a resultant force. And essentially that's the idea. Okay, an object moving with a velocity v has kinetic energy k. If the velocity of the object doubles to 2v, can you see? We are now accelerating. These two are linked, as you can see. That question 1.6 is being asked again, rather in a different manner or light, but it's the similar situation. That's if you were struggling to find sense in that, this should highlight how you should answer in 1.6. Sometimes questions can be designed to assist a student who may perhaps not get the idea the first time. All right, and this one helps to drive it home. The net work done will be, okay, so we need to think about it. What did we say again, guys? We know that work is equal to the change in kinetic energy. So the change in kinetic energy is half m if the mass is m. Now the final velocity squared minus initial velocity squared. Right. Now, the initial velocity was v. So in essence, we can just say this is half of m v squared minus, this one is bigger. This one is bigger. Let's not be silly. Let's substitute properly. So this is 2v squared minus v squared. So this is half m. Now this is 4v squared minus v squared. Actually, we don't need the square bracket anymore. Now this is half m 3v squared. Now we can see that our work is going to be equal to half. When we multiply, basically it's just going to be 3 over 2. 3 over 2 mv squared. But now we want this to be equal to k. So we know that essentially k was just equal to half mv squared. So now we want to compare this to k. We factor out the 3, we get half mv squared. So this means this is 3k. So that's C. So this is a higher grade question that says a bit of an algebraic stuff is important to consider here. Again, it takes understanding maths. This is why some schools will not allow a student to take physics if they do not take maths. Because without maths, how would you know what to do here? The factorization and all these things are mathematical gymnastics. So, unfortunately, you cannot escape them here. Right, 1.8 says, an observer stands at a distance x. C stands. So that means the initial velocity is 0. From a stationary ambulance blowing its siren at a certain frequency. Again, the ambulance is stationary. Again, its initial velocity is 0. Right. Now, the pitch of sound that the observer hears compared to the pitch of sound produced by the siren will be, of course, it should be equal to, because they are both not moving, so there's no relative motion between the two. Guys, be ready though to be asked a question when both the observer and the the source of sound may be moving, and not one stationary and the other one moving. Be ready, because we use the concept of relative velocity, meaning we stop one, and if we do so, we should do to the other. More like dealing with equations. What you do on the left, you do on the right. So such things can be a nightmare for students, because examiners, guys, are always creative, and if they are creative within the concepts that you have learned, then there's no excuse for you not knowing your stuff very well. This is to suggest, guys, once you study materials that are taught in class, that are provided in the textbook, you need to do more search. That's why there's libraries. Read on these things, even slightly beyond your level, so that your understanding is much wider and you can respond to any question with the basic understanding that you have. There's no excuse, guys, for just reading what is prescribed. We live in a world of knowledge. There's no excuses. We were restricted to textbooks, a certain textbook in a particular school. you guys are not limited to that anymore. So please don't cheat yourselves. Okay, so this is good. Again, we can think about it in terms of what we call, think of it in terms of the Doppler effect equation. We know that the frequency of the listener is going to be V of the sound in whatever medium minus the velocity of the listener divided by the velocity of sound in air plus or minus the velocity of the source and the frequency of the source. Now we know that this is 0. We know also that this is 0. We know that this is 340. It's a constant, 340. So in essence, this divides to 1. So everything here solves to 1. So we know that FL ends up equaling Fs. You can work it out. You may just think about it critically. Either way, that's a very simple standard grade question. All right, so 1.9 reads that the graph below, not drawn to scale, shows the relationship between the electrostatic force exerted by 2 point charges on each other and its distance between the charges. Right, no problem. So we see that it is F when the distance is 3 times R. So what will it be at X? Okay, it seems to be the case here. Now, which one of the following is correct? Is the correct representation of the magnitude of force X shown on the graph? Again, there's no guesswork that can apply here. Now, let's have a look, guys. What happens here? We can say, let's start with this one here, because this is where we can see something. This is now working backwards. This is again a higher grade question where the examiners are forcing a student to work backwards rather than forwards, which was usually the case. So we know that the electrostatic force is equal to basically the Coulomb's constant times the first charge times the second charge divided by 3 R all squared. This means the force here is going to be basically 9R squared. So we can even deal with this a bit better and say, what about we factor out this situation? This is basically F is a quarter, it's 1/9 of KQ1 Q2 divided by R squared, so that we can see this is the coefficient to our equation. Now let's look at it when it's just a little less than that. So we will say that FE is going to be K Q1 Q2 divided by just R squared. Now we will see that what has changed. This has changed. We no longer have that coefficient. So what is the relationship between these two? It means if we reverse what this is, we could easily say this was a 1/9 times 9 KQ1 Q2 over R squared. Right? Because we can see that this is a 9th of this. So this means for us to then end up like that, it means this one should be essentially 9 times that force F, isn't it? Or perhaps put it this way differently and say this is 9 into 1/9 KQ1 Q2 over R squared. Right, because we see that if we multiply this 9th by 9, we end up there. Again, it's a logical game, guys. So this means this one should be 9 times. Very important. So again, guys, mathematical backgrounds. A strong mathematical background is a necessity here. Okay, last question says 3 identical charges X, Y, and Z are arranged in a vacuum as shown in the diagram below. And we can see one thing, that these are all positive charges. So they are of the same magnitude. So they will repel each other. It says now, which of the following vector diagrams not drawn to scale the forces acting on sphere Y? Right, so there's sphere Y. And the net force on sphere Y, the resultant. All right, we know that this force will experience an upward force due to sphere Z. So this is going to be the force on Q, sorry, FQ by Y, isn't it? Or should we say the force of Z on Q. Right, or in fact we're using Z and Y because that's Q, 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 so that's going to be force of Z on Y. And this will experience a force in that direction. This is the force of X on Y. Now using the parallelogram method, we will see that these will have to meet somewhere there. Right, okay. Not exactly nice at this point, but we know that our resultant force should be in that direction. But we can see that essentially the force of X on Y is wrong here. Automatically that doesn't become an option. Even this is wrong. The resultant force is wrong. So A is out. F of X on Y is wrongly directed. Again, this is already wrong. This is not right. In fact, these two are one and the same thing. This is when we just shifted this force up here. We can shift forces to create a triangle like that. So, no. A and C are out. And then we look at B. We will see that this force is correct, but this is not correct. As a result, this is wrong. This was correct, by the way. This was correct. Now, this leaves D. Let's see, the direction is correct of F of Z on Y. This direction is correct for X on Y. And the resultant force is correct. But the problem here was just the labeling. This is what was wrong. The labeling. And of course, what did we do? We shifted the force here. We shifted this force of Z to here, which we can do. So that is good. So, of course, in a situation like this, you choose the best answer, even though it's not correct because of poor labeling, but it's better than the rest. So again, maybe this was deliberate to see if students know the concept of choosing the best answer over a correct answer per se. All right, folks, so that's it for that component of MCQs. So I hope I was as clear as a white goat on a black background. Now let's have a look at question 2. So question 2 reads, a block of mass 8 kilograms is placed on a horizontal surface and is connected to an MKG block which hangs vertically by means of an inextensible string that passes over a light frictionless pulley, is shown in the diagram below. Okay, a force of 76 newtons is applied horizontally to keep the system from sliding downwards. To keep the system sliding downwards at a constant velocity. Now, what does this constant velocity mean? The resultant force is 0. And if it is 0, it also means the acceleration is 0. Newton's second law of motion. So we need to think about these kinds of things. This is a typical grade 11 question. Now, we can clearly see that everything is perfect here. We just have to deal with the situation. Now, if we're sliding downwards, it means the direction of motion of this box is like that, and the direction of motion of this box is downward. So we need to think about, so we're essentially moving to the right and down, depending on which block we are looking at. Now we need to state Newton's second law of motion. Again, guys, if one does not understand or doesn't know definitions, it is high time when you get stuck or you choke on a definition, you sit back and you go back to the topic, you read everything there, you make sure you read all the definitions, and you make sure you practice recalling them, but rather avoid cramming these, because under pressure I will still forget or perhaps put it wrong. Try to understand by taking examples as to what is the implication of the definition. Okay, so we know that Newton's second law of motion states that when a body is acted upon by an external resultant force, it will accelerate in the direction of the force, such that the acceleration is directly proportional to the force and inversely proportional to the mass of the object. Okay, quite a wordy definition there, or principle, but again, guys, this is captured by this business. F res equals ma, and from here we can see that what is the essence of this is that the force is directly proportional. In fact, let's put it this way: the acceleration is directly proportional to the force, while the acceleration is inversely proportional to the mass of the object. So this is the symbolic construct of this definition. So if one forgets this, write down F resultant equals ma, then capture the fact that A and F, they are on either side of the equation, so there's a direct proportion. As one increases, the other one increases. But since A and M are on the same side of the equation, there's going to be an inverse relationship with those two. If one increases, the one decreases if we keep the force the same. Right, so this is essentially what we are talking about here. And of course, we know that the mass is a natural constant at this stage. An object normally does not lose its mass. That's why we are able to do that. But if we were to say the force is to be kept constant when the acceleration, okay, let's not talk. It's nonsense what I'm going to say. Right, so let's leave that. Let's leave that alone, please. All right, guys. All right. Okay. That's it. No issues there. Again, we get 2 marks by capturing these proportionalities. You see, these proportionalities are the most important. But again, we need to state that this is a resultant force, not just any force. Okay, so guys, that's it for 2 marks there. Not very difficult to get. But students still manage to lose those marks. Surprising. Draw a labeled free body diagram of all forces acting on the 8 kilogram block. So of course we see that we need to do a free body diagram. It's not a problem. So this, we will have vertically directed forces. Because the gravitational force is always acting. So if you write this label Fg, that is acceptable. You don't need to explain it or to write it in full. Then we know that there's going to be a force in that direction. Sometimes we can denote this with a capital letter T to suggest tension on the string. Again, you don't need to write it in full. And we will have a 76 Newton force. By the way, should be more or less I don't know if that is a necessity per se, but should be more or less equal to our tension. So we can say this is the applied force. Can even write it nicely as it is identified. But even if you wrote F, it's not a big deal. Just F alone is enough, guys. So that's the applied force. We were doing constant velocity, and we were not told anything about that there is friction here. So if there's no friction, but I'm looking at the marks, there's 5 marks. Did we miss something? Yeah, but this is not fair though. We cannot have 5 marks. But again, maybe it's just the examiners trying to act all silly, because you see, we cannot use what is provided in 2.3 to answer, an issue in 2.2. This is ridiculous. I don't know why, but perhaps the mark allocation would be suggestive, but you see, it's not mentioned. There's not even a suggestion in the opening statement that there is frictional force. So I feel the 5 marks is unfair. So that question should be up to 4 marks. But again, since we know now, we can say there's going to be Fk because it's a moving object. But again, folks, I have a bit of a beef with this one because the opening statement did not suggest anything about friction. So it's not acceptable to have to consider it in 2.2. So, yeah. 2.3. We are told that the coefficient of kinetic friction is 0.2. We need to calculate the frictional force acting on the 8 kg block. So this is easy. We know that frictional force is mu k times the normal force. So mu k is 0,2 into, we know that the vertical forces here are balanced, right? Because this object is not moving vertically. So the normal force is equal to the gravitational force. So we are able to calculate the gravitational force. So this is going to be the mass, which is 8 times 9,8. Therefore, our frictional force is what we will find just now. So 0,2 into 8 times 9,8. So we get 15,68 newtons. Now, this thing did not say magnitude. So now what are we going to say? Direction to the left. Because we were given indication that these ones are going to be moving downward. And downward here is essentially to the right for the 8 kilogram block. And friction on that is going to be to the left. At this point, the direction is important. If it is not mentioned, the mark for the last part is lost, okay? And by the way, here every force gets a mark. But I have a beef with that FK because there was no indication that it should be considered. Yeah. So with physics, it's a mark for that. Substitutions, but this substitution was a calculation per se. Because calculating FG was a calculation on its own. The final answer has to go magnitude, unit, and direction. If that is missing, that last mark is going to be lost despite a correct magnitude. Right, so it's all three: magnitude, unit of measurement, as well as the direction. A vector demands respect. It's an adult in physics. Can't just call it by name. All right, okay, all right, let's move it down a bit. So we were supposed to have, yikes, we are supposed to have 2.3.1. You see now this thing, let's just run thick. I didn't choose this, man. Is wrong. Anyway, 2.3.2. We need to find the mass of the hanging block. Not a problem. So what do we need to do, guys? Well, we can use the fact that we are doing constant velocity here. So the mass of the hanging block, it's going to be quite tricky, is it not? Let's think about it. We don't know the tension. But now we know that that applied force together with friction on the 8 kilogram block is going to be equal to the tension, right? Right. So this means the tension. So we can see that, okay, for that 8 kg block, we will see that there's that applied force of 76 newtons. And we saw that there's going to be friction, which we just calculated, and then there's tension. Now the tension is the same as for the, what you call, this block, Ibo. Alright, so this tension, because the pulley system is frictionless, we know that this is still the tension and the gravitational force. Because the gravitational force is bigger than it is for the other one. So we need to think about this. So this is easy because we know that these two will add up to the tension. Because there's no acceleration, there's no resultant force, it's zero, so these ones should cancel out nicely. Yeah, so that's the same thing. And again, we understand very clearly that the tension also here should be equal to the gravitational force. So our key is to find the tension, because now we cannot say we know the gravitational force, but we are able to find the tension. And the tension will then give us the gravitational force. Right, so let's go. We will see that, okay, for the mkg, it is such that the resultant force is equal to 0. This implies that you will have Fg minus the tension is equal to 0. So Fg is what we want. We know that this is m times 9,8 minus the tension is going to be the applied force, which is 76, plus the frictional force we got is what we have there, which is going to give us 0. So we can see that the mass of our object is going to be 0 plus 76 plus 15,68, all divided by 9,8. Right, which is going to give us the answer. So this is 76 plus 15,68 divided by 9,8. 76 plus 15,68. Then we divide by 9,8. So the answer here is 9,36 kilograms. Okay. So as you can see, guys, a bit of strategy here is very important. And of course, a student who's been following my channel, these questions are not at all a difficulty. Because if you realize that the force diagrams at play are these two, and one assists the other, then it's easy to move forward. We can say this is good, and the general substitutions, and then the answer. But remember, we need to see the unit. But since mass is a scalar quantity, we can easily forget about we don't consider direction. Alright guys, so we've got a 2.4. Says the applied force now acts at an angle theta to the horizontal as shown in the diagram. Okay, same scenario, but that force is now acting at an angle theta. It says what will be the effect on the following. So these questions, guys, these are the higher grade questions. There is always one single question about some interpretation of what will happen if things change around. Now it says choose increase, decrease, or remain the same. What happens to the coefficient of kinetic friction? So we need to think about that. What will happen to that? Now remember, the coefficient of kinetic friction is basically the frictional force itself divided by the normal force. So it's a ratio of those two forces. Now we can see that the coefficient of kinetic friction in essence is inversely proportional to the normal force, because I think that is what we can talk about. Friction at this stage, we don't know. It's a question mark. But now we need to think about what happens to the coefficient. And that we can get from the normal force, provided we assume friction is kept constant. Because there has to be a constant before we can say something is happening. We can only think of the coefficient if the frictional force is the same. Okay? All right, okay. Is that fair? But I think I'm overthinking this question, am I not? Why is it 1 mark? Remember, the coefficient of kinetic friction depends on the surface as well, is it? Yeah, it remains the same, but what may change is the frictional force. So no, it's constant. Remember, this is a constant. By the way, I forget. This is a constant. It's not something we need to work out, because then we'll be talking nonsense. So yeah, it's a constant. So this one is a constant. So that means it remains the same. Okay. Yeah, it's a constant. Please never forget, it depends on the surface type, not necessarily. Yes, we can work it out if we can keep something the same, but essentially the frictional force here will change because of how that force is acting. So yeah, it remains the same. Easy 1 mark. So as you can see, guys, it's not just a walk. You have to think critically. Now, the kinetic friction acting on the 8 kg block. Explain your answer. Obviously, this one will decrease, isn't it? Yes. Now, let's say a student is like, how is it possible? Now, let's look at a free body diagram on the 8 kg block. So what happens here is that we will have a force down, the gravitational force. We've got the force up, that's the normal force, right? And we will have the tension, and we will have this force acting like that. But now this force will break into components, the horizontal component and the vertical component, and these are perpendicular to each other, and we've got theta there. All right, okay, all right. Now folks, if we think about these forces, we can clearly see that our main target for all of this is to try and find the normal force. So what is the normal force in this case? We know that Fg unfortunately remains the same, it's constant. It's not going to change as long as the mass is constant. Of course, if the mass changes, then that's a different story. So what can we do with this? We will almost realize that of the vertical forces, therefore, Fg, which is constant, because the mass didn't change, is going to be equal to the sum of two forces now, whichever is bigger than the other. This is going to be the y component of the applied force as well as the normal force itself. Now we can clearly see initially The normal force was equal to the gravitational force, isn't it? That was the initial scenario. But now, because of this force acting perpendicularly like that, therefore it means we're going to add a vertical component to the normal force to achieve the same issue. So it means now the normal force will have to drop to accommodate this extra force, so that they together can give us our gravitational force. Now, if the normal force decreases, then what happens? That means the kinetic friction will decrease, because we know that Fk is mu k times the normal force, meaning Fk is directly proportional to the normal force. So if the normal force decreases, the frictional force will also decrease. Of course, this is a constant. So you can see, guys, this is not one question you just answer without thinking. Can you see the amount of work put before we can think about answering that question? There's no guesswork here. And you're not just going to look and sniff and you get it right. You work it out. So now we need to structure some pieces of information here. We can say now, of the vertical forces acting on the 8 kg block, Fg is going to be the sum of the two, right? So we can say, well, of the vertical forces, sometimes just be as clear and direct as possible, of the vertical forces acting on the 8 kilogram block. It is such that Fg, a constant, we need to state it, is going to be equal to Fy plus the normal force. We can say which implies the normal force will decrease. Right, because of course to add some other force, the normal force will have to decrease, because now there's two things adding up to a constant. Yeah, to decrease. Okay, we can stop there. We can then say, since kinetic friction is UK times the normal force, it implies that Fk is directly proportional to the normal force. And okay, maybe let's just stop there. Okay, we can say therefore Fk will decrease as the normal force decreases. Nice. Can you see, once you put a structure, it becomes easier to put an argument. Of course, be creative, guys. Within that creativity, try to be precise as well. Okay? And this comes with practice. If you don't practice these kinds of questions and you don't get used to trying to explain a rather complex scenario in a very nice and summarized fashion. This is why, again, in English, you are taught how to summarize things, so that even though you may have read a very long passage, you take what is the essence of that passage and then you write only that. Because by summarizing, you're not losing the essence or the gist of the passage. but the passage has gymnastics just to entice someone who is a linguistic or who loves languages, or at least to overly emphasize certain ideas. But doing so doesn't change the fact that this is the essence of the story. As you can see here, there's a lot we wanted to say, but we then have to zoom into what is going to give us a justification for our answer. So that's how we answer this one, guys. We get a mark for decrease. And then we need to say the part that says the normal force will decrease is key. The rest was just to set it up. And of course, to say the normal force is directly proportional to the kinetic frictional force is another mark, okay? Right. The answer was already chosen, so we're not going to mark it, but we still have to make that final conclusion. All right, guys, so that's it for those 18 marks. As you can see, they were quite nice. And please, folks, in the finals and in the trials, this kind of a question gets asked in this manner. There's always some easy questions at first, and then there is this higher grade segment where it takes precision and very solid knowledge to answer questions. And it doesn't mean those marks should be lost, guys, because these are the marks that separate those who get distinctions and those who do not. All right, so let's move on. So let's look at question 3. So question 3 reads, consider 3 planets, A, B, and C, arranged in a straight line as shown in the diagram below. And we can see the masses and their radii. Okay, very important. These are all in kgs and meters, exactly the units we need. Now, first thing, we need to state Newton's law of universal gravitation in words. Again, guys, these are easy marks for those who really do their work. There's no excuses here. So this one says every particle in the universe attracts every other particle with a, is it gravitational force, Kanin? With a gravitational force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. But sometimes one may substitute this with the word body, because you know what? Yeah. But at the end of the day, guys, if the science or the principle is not bridged, for me, other issues are not so much of a big deal. So what we care about is that this is the force of attraction. And I'm not sure if it's gravitation or not. But yeah, the proportionality is what matters here to the product of the masses and inversely proportional to the square of the distance between them, or sometimes between their centers. Right, so again, remembering this from the formula sheet, we know that this is the case. Okay, so if you forget, please just remember the formula and then state this using the formula. Make sure, guys, you have things that can assist to come up with these things, even if you forget. Learn to just describe what you see. So 3.2 says, calculate the gravitational force exerted by planet A on planet B. So that's easy. We know that FG A on B is going to be the big G MA MB divided by R squared. So this is 6,67 times 10 to the minus 11. The mass of A is 6,42 times 10 to the 23. That of B is 5,98 times 10 to the 24. By the way, what is planet B? Seeing this mass and this radius. It smells like planet Earth, isn't it? Let's see. It smells like the rat. And the rat is mass of the Earth. Let's see, where is the mass of the Earth? Yeah. Joanna, this is the one. Yeah, well. And let's see. What was the radius there? We will see. It's the one. It's the one. So again, guys, you need to remember these things, right? Let's see if this is correct here. 6,67 times 10 to the minus 11. Please don't confuse this with the Planck's constant, which is 6,63 instead of 7. And then that times 10 to the minus 34. Okay, so that's it. Now the problem is down here. Now let's handle this business. So remember, guys, the distance between them will include the radii. It will include the radii. Okay? So we need to add the radii to this distance. And remember, this must be in meters. So 1.5 kilometers. We times that by 1,000. In fact, we can just do one big substitution here. And say, okay, fine, this is going to be the radius of the first planet, A. So what was that radius? It's 3,93 times 10 to the 6. We add the radius of the planet B, which is Earth. So this is 6,38 times 10 to the 6. Right, and then we add that distance between them. So this is going to be 1,500 times 8,000, isn't it? Yes. So we square this thing. Right, so let's just do it as we see it, because we need to convert that to meters. So there's 1,000 meters in a kilometer. All right, so let's start. 6,67 times 10 to the minus 11. into 6,42 times 10 to the 23 times 5,98 times 10 to the exponent 24 divided by 3,93 times 10 to the 6 plus 6,38 times 10 to the 6 plus 1,500 times 8,000. Guys, here substitutions are key to do well. If not, it becomes a horrible situation. It's quite a big force. So this is 1,8, 4 to 2 decimal places times 10 to the 24 newtons. Okay. And of course, this is attraction because this is exerted on each other. But let's see, it's exerted by A on B, so it's going to be to the right. Or we can say towards A. Because this is a vector, guys, direction becomes key. If the direction is not given, the mark is lost, okay? Formula, always we get a mark. The substitutions in general, we get a mark. But then this calculation here is a mark on its own, meaning the denominator. And then the mark here is for magnitude, unit, and direction. If any one of those is missing, that last mark is lost, okay? Remember that. Okay, so 3.3. We're told that planet B experiences a zero net force due to planet A and C. Calculate the distance x on the diagram. Okay, that's not a problem. So this is very easy. So technically speaking, we are trying to say the force due to A and the force due to C on B is equal. Okay, that's what we are saying. But now we're going to consider these together as a unit, because that would be the force between the two. So if we can know the force, which we do, then we are sorted. So we can just say the force of gravitational force of C on B is going to be equal to the force, gravitational force on, of A on B. Because if we have a zero resultant force, this is what it means. So this implies that the force of gravity of C on B is going to be G, big G times mass of B, mass of C, divided by R squared. This one must keep quiet. Come on. Come on, come on, come on. Haye menyan. Trompaizisa. I don't want to stop now because, guys, I just want to take a nice long break. So what's the mass of planet B? It's 5,98 times 10 to the 24 times that of C, that is 1,92 times 10 to the 25. All of this is divided by essentially the sum of their radii. Remember, these radii are also at play here, so they must not be forgotten. So it's going to be the sum of the two radii, which is 6,38 times 10 to the 6 plus that one is 7,20 times 10 to the 6 plus the distance x squared. And what was this force? It's 1,84 times 10 to the 24. Of course, this is all over 1. We do our gymnastics nice and easy. So this implies that we are going to do what? I am thinking we will be able to succeed because we can just switch positions of this, this goes there, that comes down. It's as good as that. You see, sometimes when you know things, guys, that's what we need to do. And essentially, for us to succeed, we will need to take the square root of whatever is here. From that square root, we then transpose this to the other side. So we can see that x here should be equal to the square root of 6,67 times 10 to the, I don't know why I'm squashing everything here. Everything. So this is 6,67 times 10 to the minus 11 into 5,98 times 10 to the 24 into 1,92 times 10 to the 25. Right. All of this is going to be divided by 1,84 times 10 to the 24. And all of this is going to subtract this sum. 6, okay, now let's just add those numbers before they horribly give us a nightmare. Okay, 6,38 times 10 to the 6 plus 7,20 times 10 to the 6 as well. So this gives us a very tasty number there. So we get 135 and then 80 scored. So basically that's 135,080,000. Okay, that's fine. So essentially that's gonna give us the value of x, guys. Easy stuff. As long as one knows the gymnastics necessary, you just do it. If you don't, goodbye to those marks. 6,67 times 10 to the minus 11 into 5,98 times 10 to the 24 into 1,92 times 10 to the 25, all divided by 1,84 times 10 to the 24. So there we're gonna minus 135,080,000. Get a very nice number there. So some smart people can do this, You can just say this is 5, comma, we shift all of this 0 and 9 times 10. What we see now, we've shifted how many numbers? 1, 2, 3, 4, 5, 6, 7. So we're going to say times 10 to the 7 meters. Or write it as it appears. This is 509, 3, 4.184,49 meters. So you've got an option there to present that answer. But know how to do the scientific notation to clean up a very horrible value. Alright guys, so this is not a very difficult question either. It's a very simple calculation if one understands what this means. So this substitution here is key. And the general substitution is key. The calculation thereof. 3 marks. And yay wena funa ukwenzani ngiyazisiqhela kodwa kutheni izoba 6 marks guys, like 1 2 3 4 qha kaloku 10 ngizonikezwa more yasibhayizisa, maybe for knowing this is the case. Okay, 5. And of course the formula. Okay, I understand. Sendiyalibala uba kanene senze physics. Asenzi e-maths. So physics is applied maths. Okay. Sikuvile ke missed. Alright folks, so as you can see, nice and sweet marks to score there. Let's get to VPM. The student's nightmare. I don't know why students struggled through this question, because in grade 10 guys I found equations of motion the easiest to deal with, although questions can be quite interesting. And the funny thing about it guys, if you look at this in terms of calculus, when you go a bit higher, this is differential equations, this is differential equations. So yeah. Is like this, is like that. Okay guys, I was just checking those messages. Now let's read. The velocity time graph below, not drawn to scale, shows the motion of a ball from a certain height above the ground. The ball bounces a few times and all sections of the graph have the same gradient. What is the significance of this? On a velocity time graph, what is the gradient representative of? Acceleration. But now, on a falling body, right? What was the story again? Not drawn to scale shows the motion of a ball from a certain height. Since this is VPM, this is already suggesting that we are dealing with G. Why? Because we are to ignore the effects of friction. Friction. Sifuna ukuyiva loo nto le. Ngoba xa ingakhange ithethwe laa nto, ithethe into yoba le nto asikwazi ukuthi i-acceleration yethu izoba i-gravitational acceleration. Okay? Ukwengezeleleka kwantoni? Kwamfutho. I-velocity ngumfutho mos, andithi phaphatheka. Yeah. So ukwengezeleleka komfutho apha kuzokwenzeka ngokwenxa yantoni? Yenzonzobila. Yazi inzonzobila. That's the center of the earth. Oh God, man ngandifundisa isiXhosa nizondiphaphela. Anyway. Right. Right, let's look at this graph, by the way. So this is the rest position, the origin. Now this tells us that anything that touches or crosses there, it's 0. So this means the velocity is 0 here, and the velocity is 0 there. Right. And we were told this ball is from a certain height above ground. We were not told whether this ball was projected or it was thrown, whether it was thrown up and then it started going down. We have no idea. But let's have a look at the sketch, because the sketch will tell us exactly what's happening. Now, can you see we started from some initial velocity 0. So if we're starting from an initial velocity 0 and we start moving, this is falling. This is falling. Or it's dropping, or it's being dropped. Because we started from rest and we started moving. So if we start from rest, from her height, and we're moving, we know we don't have an initial velocity, or the initial velocity is 0, then it means this is a falling object. It just dropped from that height. And we can see that this drop is such that going up is considered positive. So this means we took downward as positive. So very important to look at these graphs and find out those pieces, because here the examiners have already made the choice. It's for us to follow that choice. In essence, they made this choice so that we get the chance to decide ourselves too. Okay, so we can see that this is when it hits the ground. So this x is ground. So meaning the value of x gives us the height from which this ball was dropped. And then it bounces. We see this is a bounce. And of course, we will see that this is the collision time. From 2 to 0, 2, to 2, 2. From 2 to 2, 2, this means the collision time is 0, 2 seconds. And then, oops, there we are. This is the bouncing off velocity the first time around. And of course, this is supposed to be minus 18 and minus 11. Right, and then again, this ball will start to move up, decreasing its velocity due to gravity until it reaches maximum height after the first bounce. And then after that, it goes down. And we saw that the height that it went up to is just 15. The velocity with which it hit the ground, So now technically this is the velocity of hitting the ground. I'm thinking height now. No, that's the velocity with which it hit the ground the first time. And this becomes the velocity with which it hits the ground after the first bounce. And then again, we see that there is collision time here from some t value to 7,5. Now we need to find out what is this t, or at least think about how we're going to find out. And then we see that, okay, after bouncing, it bounces up the second time at a velocity of 11,24 upward. And then we then caught this ball right at its maximum height, which means this whole motion took a total of 8,7 seconds. Right. But now you see, the problem is this. And I'm sure this statement that says all sections of the graph have the same gradient, because you can see this was badly drawn. As these ones are almost parallel, but this is badly drawn. It may give a different impression. So please, people who draw things, draw properly. There is no excuse. But again, this could be deliberate. Remember, guys, as much as we can complain, at the same time, this is deliberate, just to see if the student listens to the given information instead of looking at what they see. Sometimes what you see is not what it is. So you need information. This is why you're told never to judge. Not to say you are not supposed to, but it's only because you may find yourself judging incorrectly with poor information, or perhaps inadequate information about what you see. Right. Okay. There's not a lot, guys, we're going to say. We'll just jump in and start working. 4.1. Give a reason why all sections of the graph have the same gradient. We can say the acceleration due to gravity is constant. Okay, can even give the value, which is 9,8 meters per second squared downwards. Right, of course we can say this represents the acceleration due to gravity, which is a constant, or we can say acceleration due to gravity is constant. Easy. We can say, in fact, we can even say it represents acceleration due to gravity. We can say represents acceleration due to gravity, which is a constant, or which is constant. Right, because we need to capture that word that it is constant, it's not changing, hence the gradients are the same value. So 4.2, that's an easy one, mark there. Asks, is downward motion positive or negative? We can see that it is taken as positive here. Again, an easy one, mark. Just analyzing stuff here. 4.3 says, how many times did the ball bounce? We can see this is the first bounce, second bounce. So 2 times. Or it bounced twice. You can say that. Okay. Easy one, mark again. What? 4.4. Okay, we need to calculate the velocity on the graph. Okay, so again here, no specification on how. Remember, sometimes we can use the graph, sometimes we can use equations of motion. The how part is any means necessary. By any means necessary. Okay, so this is very important. So please guys, be very, very, very particular about business here. So we can use equations of motion, we can use anything, because we can see that we've got time, we've got initial velocity, and we know the acceleration here. So this is easy. We can just say final velocity equals initial velocity plus g times t. Even this delta business irritates me. Okay, this is essentially the velocity equals the initial velocity was 0, gravitational acceleration was 10. No, we don't use 10. We use 9,8 times 2. Therefore, that final velocity is 9,8 times 2, which is 19,6. Now remember, this thing said minimum of 2 decimal places. We need to show that 0. Okay, now again, the question said velocity. It did not say the magnitude, so we need to say downwards. Okay, so this is very good. So mind you here, guys, if I just am losing you, because I know you guys, hey, I don't want to lose you. U means initial velocity, and V means final velocity. That's how things should be, man. Not this mess of VIVF business. It's irritating and it's just unnecessary labor for students. Don't know why sometimes, the big brains of education like to just complicate matters. Guys, we need to move from one position to the next. We cannot obsess over academic gymnastics. Why should we change the notations? Because what do we gain that we don't gain by using those symbols? Well, someone may say, well, we want a variety so that people don't get used to the same thing, but so what? I mean, for what gain exactly? We don't gain anything. What you can do is just add more in terms of the content. Then if people get used to the one, we add more, or even make it harder, okay, so that they can think at a higher level, because that's the intention. We don't want average thinkers in this land. But again, I may be very wrong to say that. Okay, I can show you how one would use the graph. To use the graph, we know that we can use the gradient. We know that the gradient here is going to be the change in y over change in x, okay? Now that we know the gradient's value is 9,8, we need to know that the change in x is basically x minus 0 divided by the change in y, it's 2 minus 0. So we can go on and say, well, x is going to be 2 times 9,8. Therefore, x is going to be 19,60. Careful. This one will give you one single decimal, but we're told minimum of 2. If you don't present the answer in the manner required, guys, because here we're not specifically looking for the magnitude. The answer must have the value correctly, the unit correctly, as well as direction. If those are missing, it doesn't matter that everything is correct. The marks get lost. Of course, any formula, knowing that this is the case, and of course the final answer. So that's the story, guys. Very easy otherwise. So these are some options, because at times you may be forced to use the graph, in which case you just have to. At times you can do whatever. Again, be able to do whatever. Right, so let's do the next question. Next question needs us to find time t on the graph. Okay. Now, we don't mind about that. There are many ways of killing this cat, but we're just gonna kill it however we choose. So 4.4.2. Well, I'm thinking of using equations of motion also, because I can consider this interval. I can use equations of motion there, or still use the graph. So let's see when we use equations of motion. We know that final velocity is initial velocity plus g times t. This implies that velocity. Now, what is that velocity again? We will see that the final velocity at that particular time, t, is 15. So that is 15 moving from minus 18. Now be careful, this is a vector, so we'll substitute with a negative. If not, there's going to be hell to pay. Plus 9,8 t. Right. Easy. So this implies that t is going to be 15 plus 8 divided by 9,8. We can say therefore t, mind you, this is a small letter t I'm using, be careful, it's not the answer, okay? 15 plus 8, oh god, that was supposed to be 18, oops. Alright, so 15 plus 18 is 33 divided by 9,8 gives us 3,3. This is 3,37 seconds. But that's not the time t. We can say therefore time t is going to be 3,37 plus. We will add the previous 2 seconds because they are part and parcel of that business. So we're going to add 2 there, and that gives us our total time of 5,37 seconds, excuse me. Okay, so we can do that, but although we know that we need to think about you know, what we are doing, because as you can see, that time t has to be greater than 5. We know that this t should be greater than 5 seconds. So if we end up with a value less, so that's the so that's the idea. So we needed to do something extra. Of course, guys, formula, substitution, the intermediate answer, and the final answer. Nice and easy. Okay, right. So we can use the graph to still perform the same issue. So using the graph, we know that the gradient again is going to be the change in y. Over change in x. So we know that 9,8 equals, now that change is going to be 15 minus 18 divided by the change in time, which is essentially just t minus 0. No, it can't be just t minus 0. We can use the small letter t here because this is just the time interval between the 2.2. Okay, I'm thinking now. I'm making an error there. So yeah, I'm making an error. This will not add just 2, but 2.2 where we started. So this should be 2.2. So this answer is not quite correct. Okay. So we're going to add 2.2. So this becomes 5,57. Very important. We are adding this 2 instead. Not the 2, the 2,2, not just the 2. Alright, so let's go on here. What are we getting? Okay, at this point I'm just going to jump for the jugular here and say therefore t is going to be, we say 15 plus 18 divided by 9,8 gives us an answer of 3,36, and then to that, okay, let's write it here and say this is 3,37 seconds. Can say therefore our big T is going to be 3,37 plus 2,2, which gives us 5,57 seconds. Right. Another person may not use the small letter t, but instead do this here, just to make it one single step. You can just say t minus 2, 2. Right, because that's that interval. Very nice, very easy. Even with this one, to avoid 2 steps, for the time t there, we can substitute the big T minus 2, 2. Makes it into 1 step. Okay. Because, yeah, why not? Sometimes better be creative, guys, because this thing of too many steps sometimes makes you not to use your head well. So we can say therefore T is going to be basically 15 plus 18 divided by divided by 9,8 plus 2,2, which gives us 5,57 seconds. I'm never comfortable with my S for seconds. I almost always put it in brackets just to make sure it's not taken for a 5. That's just me. Of course, guys, as I said, even for T, we can actually do the same and substitute like that. This becomes a single calculation instead of, needing to come up with this step. Either way, if the answer comes up nice and it makes sense, we are happy. All right, let's do 4,43. It says now the height above the ground where the ball was projected. Easy. We now know that, okay, to find the height, we can either use, let's just use this equation that, S is equal to ut plus half gt squared. Again, here, S represents the displacement. Okay. I'm tired of this delta y business, man. It's boring. It's unnecessary. As long as you know what this is. Initial was 0 times 2 seconds because it took 2 seconds plus half into 9,8 times 2 squared. Therefore, S is, okay. So this is 0,5 into 9,8 into 2 squared. So this gives us 19,6. Careful here, 2 decimal places. Meters, we can say therefore height is 19,60 meters. What was the question? It said height above ground. So height is a vector. We don't need to say it. But if the question was position, we would have to state the direction that this is above ground. Okay. So, very important. Very important. But again, there's no harm if you get confused to even state. You don't get an extra mark for stating direction for a scalar quantity, but you do this when sometimes the question is from what position. Now that word position represents displacement. Easy stuff, so nothing to complicate there. That's what we get in the answer. And remember, the answer has to carry the correct unit in its correct format. You cannot write capital letter M for meters. If you do, you are not talking about this. But in physics, there's a bit of a situation. Small letter m represents meters as well as mass. Yeah. Remember that. So the context is what separates it, rather than, some standardization of some sort. Anyway, guys, this is easy. 3 marks, nothing too complicated. Of course, there's plenty of ways of dealing with this. We know that in a velocity versus time graph, the area under the curve represents a displacement for a velocity versus time graph. So we can use that piece to answer this. Of course, guys, I'm giving you options because the exam can come seeking one to only use the graph and not equations of motion. So we can say, well, we know that the displacement here is equal to the area under the graph for the first 2 seconds. Okay, such that S is equal to half, because it's a triangle base, times perpendicular height. So this is a half, the base is 2. The perpendicular height, we saw that the velocity came out to be 19,6, right? So we need to put the value of x. Okay, good. So let's see. So this is going to be 0,5 into 2 into 19,6. Yep, we get the same answer. By the way, the half takes each other out. Goodness, how did I not see this? I did not even need the calculator, but be careful to add the extra digit, because if not, we are dead. You can say there for the height. Always answer the question at the end. Use the vectors, but at the end we need to see an information about the height, not S. Nobody talked about S, but we used it as a means to an end. And of course, guys, this is stuff that a student needs to know by heart. There is no excuse for not knowing graphs of motion. Graphs of motion need to be known. And of course, guys, formula in maths is good. Substitution, answer, and as we said, the answer has to be in the correct manner. Minimum of 2 decimal places. If not, you lose a mark for that. And of course, the unit of measurement must be present. If not, you lose that last mark. Don't care, and we are very brutal. Mind you, at the trial level, we are very brutal. I'm going to say we as if I am one of them teachers, or one of them, those people, important people in the provinces. Essentially, the level of brutality is super. It's like a razor sharp knife. You think it just cuts through things. It cuts through things. So you don't want to be cut through. There's no forgiveness for complacency. Right, maximum height reached after the second bounce. Nice and easy. After the second bounce. So this means we are talking about this area under this curve. Right. This is the one. So this is the area that we're talking about. It's triangular too, because we can calculate what is that time interval, and we can see that the height as well is just that velocity right there. So it's all good. It's nice and dandy. Sendiyarira ke ngoku, sendiririre mina ndiyarira. Okay, enough of the nonsense. Right, so we've got two options, folks. We can use our equations of motion, or we can do the things that we know. So we know that, well, velocity, what are we looking for again? Height, okay. Okay. So basically we know and we understand that the final velocity squared equals the initial velocity squared plus 2gs. Now again, please remember my s here represents displacement. Diniwe ngaba vi delta y business bayanhlanyisa. Right, at some point we've got to cut it. Noma ngabe kwenzeka ntoni, sidikiwe into engenangqondo, into engenamshoxo. Hayi man, suka hlafu nenqaphu what I call sweet. What's the point? We're inciting the enzymes in your stomach to secrete, not enzymes but the cells to secrete digestive enzymes. What are you going to digest? Because you're just swallowing saliva. That's actually not good for health actually. So kudla inqaphu akuyonto right. Sanuyitya laa nto le. Unganitya inqaphu xa sowuhlutha. Abantu xa ugqiba ukutya ungayitya ke inqaphu. Yenza ntoni? Iklina amazinyo. Abe clean, ungabi ne-halitosis. Usinokusela xa uthetha nathi. Wesi xa uthanda nohlebo. Uva umntu esondela endlebeni yakho agqiba kubethe nje ngevumba leqaqa. Uba ndiyalazi iqaqa. Shapa kale phoka la nakedi ntate. Hey, utloliwana ore akyashwa jwale. Kusakgona lo hem. Bamba ngenye asthma yeqaqa, iqakuzini. Hayi ke kodwa kusenandaba. Abanye ke kodwa, guys, be careful abazikhetheli indalo. They have problems with their salivary glands. Okay, they tend to not secrete saliva very well. So then they get dental caries and this happens. Again, it helps to drink water because people don't drink water. Even if you brush your teeth and they're clean, if you don't drink water, the saliva is not going to be as watery as it needs to be and you're going to have issues, okay? Don't do it. So, yeah, andisanabe sitting but in chill. We know that the maximum velocity, remember if velocity yaphaya not, it's right on the x-axis. So 0 squared equals the initial velocity. It's that bouncing velocity. So of minus 11,24. Again, we square that. Plus 2 times 9,8 s. We can say this implies that our s is basically 0 minus 11,24 squared, all divided by 2 into 9,8. Of course, guys, enjoy the things. Enjoy the things. So we can say therefore this implies s. Let's go for it. So this is 0 minus 11,24 squared, all divided by 2 into 9,8. Be careful of signs here. These equations use vectors only. So signs are an issue here when being used, unless everything is positive. So we get minus 6,45 meters. Remember, the reason for the negative, again, it doesn't mean it's small. It just means direction. So we can say, therefore, remember, these are vectors. So ignore the negative. It represents direction. So a negative in physics, remember, it's for direction. So if we're looking for a scalar quantity like height, you can say therefore maximum height is basically positive 6,45 meters above ground, if we wish to say that. Again, there's nothing wrong in stating the direction above ground. Extra information that is irrelevant or not necessary, there's not a crime in doing it, but this can be very protective when we have an issue. Right, now we are scoring 3 marks again here. 1 mark, substitutions, and the answer. And remember, the answer has to be the correct format, unit, okay, only. The direction is not a necessity, it's extra information. Now, I wonder what would happen if you give an extra information and it's incorrect. But in physics, the manner in which these are marked is that the first thing that you wrote is what gets the mark. So if you write perhaps a wrong thing and then you don't scratch it and suggest so, then you calculate the second time around the correct thing. What will be marked is the wrong thing, because the first thing you wrote is what gets marked. So be very careful of what you do. Now, if you write additional info and it's wrong, it already sits in the background. Nobody cares about it. Okay. Just try to not write it first, because then you're gonna sabotage the correct answer. All right. Okay. As I showed, guys, that we could actually use our equations of motion. Our area under the curve here. We can just say, well, this maximum height is going to be basically half base times perpendicular height. So this is 0,5. The base is the difference between 8,7 and 5,5. So this is 8,7 minus 5,5 times the height is that distance there, which is essentially 11,24. And in this formula, nothing should be written as a negative. So 0,5 into 8,7 minus 5,5 into 11,24. Voila! We get 17. Hayi. Hayi, impendulo yam phayana isnaks nje. Asikwazi ukundiqhatha kaloku. Khona ntoni engekho right ngoko. Intoni ngoko. Oh, I did not square phayana, man. Yabona. That's why ndibethile ndiye ndalibala ukusquarisha above. Okay, guys, again, this further emphasizes the fact that one needs to be careful. Sometimes performing 2 calculations just to check, sometimes I recommend this, especially when you're cruising nicely. Just check another technique, just in case in the one you did above, you made a silly mistake. Like for me, I just forgot to square. And as a result, I crippled my answer badly. You see, hayi ke ngoku mandingaqelwa kakubi. Mandingaqelwa kakubi. Ntoni ngoku? Ke enjwale. Theni zangafani ezi answers. Nikeza the wrong answer still. But there's no crime. I didn't do any crime. I can ignore time. I can call my initial velocity the 11,24. And the final velocity is 0. And the gradient is 10. Sorry, it's 9,8. Hi, guys. Can't do anything. Why is my calculator giving me answers I don't understand? I don't know, guys, now why that equation is not working. My Lord. Because it's supposed to work. Yabona-ke intoni endiyenze wrong kanti? Intoni endiyenze wrong? Hi, angisazi, guys, but now I'm not happy. I am not happy. Oh, I performed dangerous calculations on the second one. I was wondering, hayibo, zange kaloku ndaqhathwa yi-science mna. Ngabaqhatha bonke, hayi mna. Okay, bese ndifuna ukuphambana. This one is a little less accurate, but come to an end up. As you can see, equations of motion, they tend to overestimate things rather than underestimate. Right. So I did a dangerous thing here. I think there was something I forgot to take down. So yeah, that's it, guys. So it helps to ensure that one double checks. So you see, yeah, that's just how I could give the perspective to you guys, because I need you folks to be comfortable with these subjects, like very comfortable. And I like these easy papers though, man. You can see the way they are structured, man. They just make you feel you're doing something, and I like it that way. It doesn't have to really punish too much by asking very silly questions like, who are you trying to impress? But at the same time, you can't just give students exactly homework in the exam or classwork. No, homework and classwork, they are exactly what they are. You cannot tell this is a final exam or some serious exam and we just ask homework. No, it has to be a notch higher for sure, but not too far out of reach for a student. Right. 4.5, sketch a position time graph for the entire motion of the ball. Right. Now we want a position time graph for the entire motion of the ball. Indicate the following on the graph. Okay. So 4,5. So we've got a position time graph of ball's motion. We need to see this, a topic, guys. Can't just draw a thing and we don't know what it is. Even in maths, it says, once we say position, it's a vector, right? So we're going to consider both positive and negative issues. So, of course, time is always here in seconds. So this is going to be position in meters. That's ground zero. Right. So it says we need to indicate these: the height above the ground where the ball was projected, the maximum height reached after the second bounce, all the times indicated on the graph above. Okay. So first of all, this one came from a height. It's going to come like this. And then there's going to be some time lapse between that, and then again it goes up to the second maximum height, and then it hits the ground again. And then benifuna ke taniyofika phaqa yaniphaphela. So rotate man, ayi nawe. Ndifuna ukukunyusa wena xa. Okay, for now on papel. All right, so we know that that would be the case. And then the second bounce again ends at the maximum height, which is this one. Again, there was a time lapse before that. All right. Great stuff. So this was 2 seconds. Then it went on from 2,2 seconds, and it came down at T. What did we get, Kanin? The big T. We got 5,57. And then it went up at 7,5, yeah. And then it reached the maximum height, and it never came back down. Okay, so this one is not quite. We stopped at the maximum height. Okay, now I'm struggling. All right, let's just do this before we start having issues. We will say that, okay, it went. Say na ingolozana lento. Bikade ingandenzeli lento man. Awareness updates sanizandihlanyisa nyana. I swear to God. I hate these updates now lately because they mess up the functionality of my tablet. I'd rather it stays in the boondocks, you know, because yeah, ngathi sekufuna undihlanyisa manje. Xa nizondiupdatela iway yami bese ingasenzi into eqhela uzenza, then ngcono nivele niyeke bafethu sanondigulisa tyhini. Cimba nichaza bani xa ninimosha? Nindichaza. So what was the maximum height? The first one, this was 19,60. And then the second one over there, that was 4,4. That's the last one. And that's kind of see the second one. I can't see that second one. We only counted, we calculated this one, which is 6,75. Did we get that? Aye man. 6,45. Detain. Equations of motions are underestimated. Okay, whatever guys. Whichever we choose of those ones, it's not a problem. I don't know why it's doing that, but I should be getting the same answer. Maybe I just didn't write everything properly. You know, sometimes I do that. Whatever guys, you understand what's cooking. Now it says the height above the ground where the ball was projected, the maximum height reached after the second bounce. Good, because that one we don't know, so we don't even need to indicate. All right, all the times indicated. We have 2, 2,2, 5. Now this 5 needs to come up, because if it doesn't, dead and buried. Get it? So we need to make sure we follow instructions, guys. Instructions. So we're missing that, and that should come up. That 5 must be there. So we've got all of them. Right. So the graph is done. Of course, guys, this was a very nice question, and I am sure it seeks your attention. So we score the 4 marks for the shapes, the times, the heights, any one of them heights, and and of course the entire thing, meaning position. We need to have a topic, okay, and we must label the axes correctly. So for the entire thing we get an extra mark. Ideal. It's klar, I think. Okay guys, nice. Let's get to business. Alright folks, if you want this memo I am writing, it's in the description. By the time this video premieres, everything is there. I will put a copy of this question paper together with this memo. Okay. Now, a car of mass 1.2 kgs is moving at a constant velocity of 12 meters per second to the right and pulls a trailer of mass 500 kilograms. And of course, we need to ignore the effects of all frictional forces. Now, what do we create? If we see a car pulling things, we're thinking of, collisions. So this is perhaps us creating a closed system / isolated system. Of course, most likely a closed system. An isolated system, we need to see energy staying constant. So think about that. Right, so we can choose motion to the right as positive. Now it says state the law of conservation of linear momentum in words. Alright, so we can say 5.1, we can say total linear momentum let's shake high momentum in a closed system. Of course, you can even say isolated, but these are not the same thing. Similar idea, but not exactly the same thing. In a closed system will remain constant or conserved. Here we've got a choice, but I would rather choose closed system. Avoid isolated system. Okay? Because there may not necessarily be, a restriction in terms of energy change as well. It's not a must. For momentum, we just need a closed system. That's all. So, you see, at times you think about it. Okay, minimum is what you want to stick with, because if you're going to extremes, you're starting to become a bit more discriminatory and you're losing your path. Okay, be very, very, very careful. And of course, these things are poorly understood by many. As a result, they make them seem like they're the same thing. So I'm sure, guys, we are polishing you now. You are one of those shoes at the airport. You know, those people make your shoes shine. You can even almost see your face on those shoes. Well, I don't know when was the last time I boarded a plane. Goodness. Yeah, but I enjoy the road. I'm scared of the air anyway. So, yeah, that's the thing. When I took my first flight, it was drama. But of course, I hid it inside. Nobody actually saw it, but yeah. But anyway, what made me not even show that I was actually in trouble is that my seatmate, if I will call him, he was holding on the seat like, wow. So I was just busy laughing at him, although I was actually feeling the same heat. I was like, goodness, God combined two people who were just scared of heights. Okay, maybe I wasn't really that scared of heights. It's just that the flight was more of a challenge for me. I actually love the road. I don't enjoy the air at all. Leave the fear alone. I just don't like the air. I prefer the ground. You see, I'm the son of the soil. So, yeah. Right. Enough of my nonsense. Calculate the momentum of the car trailer system. Just the momentum. We know that momentum, guys, P is mv. And mind you, this P is not capital letter P. Don't make a mistake of making it a capital letter P. Right, so we know that P, a small letter P, the best way to represent it on a book is to have that P. You see the O part sits on the line so that the stem falls below the line. That represents small letter P. But once the P it's written like this, the P, the stem sits on the line, that represents a capital letter. So don't go around telling me nonsense here. Yeah, you don't know the difference. Yes, there is a difference unless you are taught by hooligans, and you will never know the right thing. Right. So MV, so the mass, we add the two masses. So it's going to be 500 kgs plus 1,200 times the velocity, because we'll be moving at the same velocity. Right, therefore P is equal to 500 plus 1,200 times 12. And so what if it gets? We get 20,400. Remember, this is kilograms meter per second. Again, this is a vector. So if the question said momentum, we need to specify to the right. So if you treat vectors carelessly, yeah, is that this, mainly this perhaps I think so. This mark should be over there. And the answer, of course, don't go. And the answer, again, the answer, guys, has to be with the right unit and with the direction. In fact, everything. Magnitude, units, and direction. If any one of them aren't there, there is hell to pay for that mistake. Now we're told the connecting rope suddenly breaks and the car and trailer are separated. So the break represents a collision, so to speak. Okay. Now 5.3 says, in which direction will the trailer move the instant the rope breaks, and state a relevant physics law to support. We are stating it, we're not mentioning it. So we know that the trailer will, because of inertia, and well, momentum too, because inertia is because of momentum, essentially, is Newton's first law. So we know that it will move forward or move to the right. It will continue to move to the right, okay, due to Newton's first law of motion, which states that an object will remain at rest or continue to move at a constant velocity unless it is acted upon by external resultant force. Oh, that was quite wordy, but we have to. So for the first part, it will continue to move to the right. That's a mark. Now, due to, we mentioned Newton's first law of motion, and we stated it. So the stating of it is actually 2 marks. Right. So that's how we score those 3 marks there. 5.4 says calculate the velocity of the trailer after it's separated from the car. Right. So we know that the total momentum before is going to be equal to the sum of total momentum after collision. Now, this means we're going to have the mass of the trailer. Okay, mass of the trailer times its initial velocity plus the mass of the car times its initial velocity is going to be equal to, actually these two are a unit. So it's going to have mass of trailer plus mass of car times the initial velocity equal to mass of the trailer times the final velocity plus mass of the car times its final velocity. But we have a problem, don't we? We were not told what the velocity of the car is going to be. But we know the car was moving at constant velocity, so it's going to continue. Wow, this question. Yawana, you are a big boy, if not a big girl. But girls don't like to be called big, so you are a big boy. Yeah. Or a feisty girl. Hey, Kalesa. Adichethaga lot nasine na continuous ngoba feist. Kodwa bakhona ke ababukeleyo abayi-understandayo le nto ndiyithethayo yafumana. So nina ningayifumani nje, ningazami nozama ukuyifumana. Sizoxabana. So sibalile masiphayana le. Apha we don't need to do anything. We just put the 20 squared or 34. Yayibona yengo. So sesiza apha sithi ngu-500 V plus 2000. Is it 2000? That was 1200. So it's 1 squared of 32. That one remains 12. I can't change a constant. So this implies that the velocity of the car is it's 20 squared of 34 minus 1200 times 12 divided by 35. Therefore the velocity of the car, the velocity of the cat. Do you see there that this becomes easy when we know what we're talking about? Not too many subscripts. Oh, my battery is trying to leave me. My battery is trying to leave me. No, man, you can't leave me. Not like this, mas. That is near, man. Near. I don't agree. You see, must you always do this thing, must. You are going to do what I want. Okay, 5. What is this one? Yeah, earlier. now in meters per second. And can you see the answer is positive to suggest that we are moving forward? I got yaqoka man. Yeah, wena. Sinhlanyisa wena baliza ngiqalam na. Funa ngikhulisa. Yabana man siniphaphela wena man. Skamphaphela. Hey, it's still continuing at 12. Hey. Yabona nyani selilo of inertia bafowethu. Ngoba kho friction. It makes sense that it's going to continue at 12 meters per second. Qha ke ngoku umvavanyi wethu to the right. Umvavanyi wethu is trying to prove that point, that actually this could be a 2-mark question instead of a 4-mark question. Because honestly, if there's no friction, then yeah, if man, finally qhubeke ingayeki. Same velocity. If the car maintains the same velocity, you see. Yes. This question is beautiful, man. I need to kiss you in the forehead, Moss. You're a beautiful question. Whoever made this question is a genius, and not just a genius, a physics fanatic, an enthusiast of the subject. And this is beautiful to see. I love it. Like yo. See that one. Max. Remember, this is a vector. We can even say 2 marks this time, because to make up the 4 marks, I don't see why we should get 4 marks elsewhere. But one may consider saying that since nothing was mentioned, it had to be logical to decide to put that 12, and we could give a mark for that. But remember, we may still give 2 marks for the final answer. That means everything must be proper, guys. Magnitude, units, direction. Right. So this is proper. So what type of a collision is this? Elastic collision. Because there's no loss of kinetic energy during this break, whatever this is. So in essence, this is an isolated system as opposed to a closed system. But it helps to know their things nicely. There's no excuse for not knowing things right. Yeah. Now use the relevant calculation again. Forcing us. It's obvious. It's obvious. Ay man. Ay. Yabona ke ngiqala unihlanyisa ke ngo. Awunikwazi ubuza into ecaceca njengale. Wanifuna sibale into esezibonakala. La mpendulo ka 5.4 seyithethile inyani nje. Ba i-elastic lento le. Hayi man. Hayi. Anifuna uniphambanisa ke ngo. Kodwa ke suphapha nawe man. Hayi yaphapha. Sisiphaphela wena man. Sum of EK before is equal to, this is half, the masses were together, that is 500 plus 1200 times 12 squared. This one is equal to 0.5 times 500 plus 1200 times 12 squared. Isinikeza leyanto. It says use the relevant calculation to determine whether the collision is elastic or inelastic. Yeah, well, we look at the system here. So even if we looked at one of them, because everything seems right. So we're getting this one is 122,400 joules. We can say the sum of EK after the collision is going to be half of 500 times 12 squared plus half of 1200 times 12 squared. We should get the same thing. 0.5 into 500 times 12 squared plus 0.5 into 1200 into 12 squared. Same answer. This is 122,400 joules. We can say since EK before is equal to sum of EK after the collision is elastic. Now, we may even start to suggest that the system is an isolated system as opposed to closed. Again, this may feel like crazy for now. You will be surprised when you see it in the finals, where you have to decide whether the system is isolated or closed. Uzozwa ngathi uyashaka emase kufika lapho ube siyashabalala bese siyagqiba. Siyagqiba thina, siyagqibana nje. Sisibani sethu leso ukugqiba nje. Asebeshabalele. Bese sibakhumbula ukuthi bayiziyatha. Izinto ezingakwazi ukucabanga impela. Yes, we have to be brutally honest, because if we're sweetly honest, you'll start to act all crazy and funny in front of us. Look at our lovely politicians, because they are so mediocre, men, in this flipping world of ours. You see, I'm sorry to be so ugly now in that regard, but because those people are average, man, there's no question about it. Most of them are average people. Most of them. Not all, but most. In fact, even those that are bright have been watered down by such nonsense they surround themselves with. You see, association brings assimilation, whether you like it or not. My problem is that with the politicians that we have, these are mediocre people who could hardly pass Matric. All of a sudden, these are the people who pose as the smartest in the room. They talk non-stop as if they understand what they're talking about. And yet they're just regurgitating the rubbish they read and hear. They don't know much of what they're talking about. If you take them to task, they'll tell you they'll consult first. See how ridiculous. And of course, you will hear people in the country, yeah, so is smart, yeah, so is our only hope. Your only hope is a ridiculous individual who's by no means, a diplomat, at least, because remember, for one to lead the nation or any nation, those people should be diplomats, because we cannot have people who can incite wars and have our country attacked or shut in the rocks for ages. No, we cannot afford Zimbabwe here. Zimbabwe is just a clear example of how people who are not exactly very clued up are not fit for office as high as that of the land. And now we have substituted noise for reason. We've substituted merit for mediocrity. How appalling. Listen who's talking. Yeah, it's me. And I'm talking to you. And whoever else is listening. Whatever the emotions I stirred in you, I am doing it on purpose, okay? So go cry. When you finish, you come back, we do physics and move on with our lives. Right. Of course, folks, we can clearly see that this is key now because we're told to do a calculation. I don't know, guys, I'm being silly now. I didn't write formulae, so yeah, I may be punished for this. And then, of course, stating the type of collision, that it's elastic. And the reason for it, that EK before is equal to EK after, is the basis. So 1, 2, 3, 4. Now, that means the formula has to appear. I'm going to squeeze it here, guys. EK is half mv squared. Forgive me for being a hooligan that I'm speaking against right now. Honestly, guys, I don't know how ridiculous we are in this land. We have our hopes on people who hardly passed Matric, who could not fully express themselves at a standard level. Can you believe it? Mind you, the Matric exams are standard at best. They are not really, what we would call higher grade back in the days, which already is saying you are functioning above standard. Even if you don't get a distinction, by just passing well in a higher grade exam already proves that you are beyond standards. Now we have people who were far below standards. They hardly passed Matric. And here now they want to educate us as a nation. Because they just read about things other people have written. Because they didn't write anything, they keep spewing in front of you. And of course, you people who are so ignorant as well. Yeah, we want land. We want land. Okay, it's a valid ask, I guess. But folks, let's face reality though. Are we even capable of using the land to its maximum effect? Or we just spoil it, we waste it. That's what we do. Truth be told, guys, we can cry about it or not, I don't care at this stage. But let's face reality, folks. We have failed to use the land available to us maximally and the right way even. I'm not saying we don't deserve our land. No, I'm not saying that. But my question is, are we ready to use it? Question is, have we used any of the one that we have available to us to any good effect so far? I doubt. But again, we cannot ignore the fact that the land was stolen. Or rather, in fact, to say it was stolen, it's another thing. The land was taken right before us. Guys. And that is a reality, unfortunately. Even those who don't like that part of my speech right now, they just have to accept it. It happened that way. Now we need to kind of balance the equation, not to imbalance the equation for the sake of that the left-hand side was somewhat disadvantaged such that the right-hand side was big. All we have to do is just to redistribute. And you see, the best way to redistribute is not to take away. Look, when you're trying to balance an equation, guys, you don't subtract. Think of physics. Instead of subtracting, we multiply more. Okay? You multiply more on the on the left-hand side. Let's say we had a situation like that. Let's say the right-hand side. Let's say it was A is equal to 5A. So you're not going to tell me that you're going to say minus 5 here, A, and then you can say plus 5A. No. Do you see you're going to create a 6A here and then end up with an A? That's not what we're trying to do here, guys. All we want is to say, fine, since kunje, le yona it is ever land. And again, wasizuyenza lanto ethi what you do on the left hand side, you do on the right hand side. Sifuna nje kube nje bafethu. Qwaba. Kosidingo soba sibe sibhanqa lapha. Khalela into esingayazi, sifune nangendlela engcolile. Engenalusini. Siphinda lento yayenziwe kuthi mos. Sohluke kanjani ke ngoku nabo bantu bakhohlakele. Ithi ingoma esasiyicula ngexesha lomzabalazo khe senza fana ndizenze ngathi ndandibhadlile ngelo xesha, kodwa ke ndandiyiva ndiphinde ndayicula kwi-concert. Ithi sithi aluta viva continue wesibetha ingqongqo oyimincili yitoyitoy madoda luvuyo Jesus bethe ingqongqo sichwayitile siyaguya, siyagida, siyaqakatha, siyaxhensa, siyajila, sibethi ingqongqo, siyatshotsha, siyasina, siyacholoza phambili, phambili. wemadiba. But abafana betena yitoyi. But was this hi nyamazan hi nyamazana. It best hi nyamazan hi. Nelson Mandela was Baba we husky was a sketchy me ka was Chinimadoda Intonile and Zekayo ho is in Yamases Ogatra Mandelu Petit South Africa Chinimadoda. Oh, but this is come yeah. Kama kolifumile ezimnyama sezingenile sitisuka wesityhadala wena nyamazana hayibo hlala ehlathini nyamazana hayibo hlala ehlathini nyamazana hayibo hlala wena nyamazana hayibo hlala ehlathini hayibo nyamazana hlala ehlathini yo nyamazana siphethe aluta viva ilizwe lelethu viva. Okay, lelethu sange sithi thina singabantu abathile lelethu nasibalance equation ke guys masingaqhelani kabi. All right, so let's look at this question 6. A steel ball of mass 500 grams. Now we don't work with grams in physics. We need to immediately convert that. So if this is 500, we divide it by 1,000. It gives us a 0.5 kilograms. Right, attached to an inextensible string hangs from a ceiling. Of course, issues of a pendulum here. That was a very nice higher grade question back in the days. The ball is held at position X, okay? Once something is held, what does it mean? Stationary. Initial velocity is 0. And when it is held, there's equilibrium. All forces are at equilibrium when it is held, right? At a height of 2 meters above a horizontal table with a 1,5 crate placed on it. Okay, so there it is, nicely shown on the diagram. When the ball is released, it collides with the crate at position Y. The crate moves to the left with a speed of v meters per second, while the ball continues its swing to position Z. And reaches a maximum height of 0.6 meters above the table, shown in the diagram below. A frictional force of 50 newtons acts on the crate as it moves to the left. And of course, we are to ignore air friction. And what does that mean? Yes. We create an isolated system. Right. Or should we say a closed system? Because that's the minimum. So when there's too much on the maximum, we would rather stick with the minimum, closed system, right? Right, now it says state the law of conservation of mechanical energy in words. Right. Question 6, we've got 6.1. We know that in a closed, or we can even say isolated. But now guys, I'm sure you know the difference. I would say stick with the closed system business here. because mechanical energy here is not necessarily talking about kinetic energy alone. In a closed system, the total mechanical energy is constant. Or we can say conserved. Very simple definitions here. Right. 6.2 says calculate the work done by the gravitational force in moving the steel ball from position A, from point A to point B. Calculate the work done by the gravitational force in moving the steel ball from point A to point B. Now where is point A? What are you guys doing now? I. Intoni ngakho point A na point B nje apha. Yabona ke guys. Don't nizomosha question right kangaka. Yabona ke. Uyabona ke. Ngokusawukhethe iphi xa kunje. Yikes. Folks, what are you doing to us? I don't understand. Let's see if we can do this without 6.2. Because, yeah, available some more question enhle ababantu. Hayi, nani kodwa dozini. Yabona moderation yeni kodwa guys yanyanyisa shem. Zonke ezi provinces ziyacaphukisa nje. Hlula into elula man. Kulifunda iphepha xa lisubmithwe zii-examiners. Hlale wena quality what and moderator and coordinate nilifunde. And anizolifunda nje ngokulipage 1, 2, 3, okay, it's fine. Print it. No, you don't send it to the printers. You sit down and work on the paper so that you can see yourselves how fast are you able to answer this question paper, because it has to still consider the fact that students need to answer this within 3 hours. Will you answer this within 3 hours as an expert? Or so we call you. If you can't, how dare you put forward this paper for students to write it? Because if an expert cannot write this in half the time required, then there's no way you can pass this paper for, a sitting by students who, by the way, are not experts. So please, folks, I'm andifuni itoy man. Kodwa nifaka itoy mo. Yibona yonke lento. Hayi maske siyibone, siyayitseba le 6.2. Jonga futhi ne question numbering yakhona injani. Hayi ke ngoku yabona ke guys, nansi ke enye into. From 6.1 to 6.4 nje kanjalo. Sure. That means there's a missing statement perhaps in between here. Maybe bekhona imbalelwano ebikhona apha. Bekunembalelwano engekhoyo apha. Okay. Senirhala nokuyiyeka ke ngole question because xa ingaphelelanga izawusenzisa amaphutha. Hayi manona kutheni ngoku asikwandenzela amapetse ngo ndizama ukuvala ndifuna ufaka into apha. Itheni ngoyazi ke yanimincela ngo tyhini. Qhaba. Kwazi uminca apha. Tyhini nabafundini. Meaning there's missing information maybe. I would suppose so, because I'm looking at the jumping here and all of that, so something is not right. Can't talk of A when there's no A here. I honestly don't understand. Because now, what are we going to have to say? Anyway, guys, calculate the speed V. We can do that. of the crate after the steel ball collides with it. No problem. That one we can do. So let's just forget about 6.2 because I don't know what that is supposed to mean. But now 6.4 we can answer. We know that first we need the speed of this guy right here. Okay, so we need that velocity, and we're going to use the conservation of mechanical energy. So we know that, well, total mechanical energy at the top is equal to the total mechanical energy bottom. Right. In fact, do we even use the sum? No, we don't use the sum. Just write it. So this implies that mgh plus half mv squared is going to be equal to mgh plus half mv squared. Now this is 0.5 times 2, times 9.8 times 2 plus 0, because there's no velocity at the top, is equal to, again, there's no potential energy at the bottom, so it's going to be half 0.5 v squared. You can say this implies that our v is going to be the square root of what we have here divided by what we have there. So this is just 0.5 into 9.8 into the masses will cancel out, so it just becomes GH. Yeah, 2GH basically. So this becomes 2GH. We don't need to worry about the mass. Moving fast, guys. So this is going to be 2 times 9.8 times 2. Because the 0.5 will divide to 1. That's the mass, right? Then we cross multiply the 2 there. It becomes 2GH. Can you see? Just take the square root. Therefore, the velocity there is going to be that square root. So 2 into 9.8 into 2. So this gives us a 6,261 to 3 decimal places meters per second to the left. Okay. Now, since everything is moving to the left in this case, we can say with the left, with motion to the left as positive. Okay. Right. So what do we do now? Momentum, 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 momentum. So we can say then, we know that the total momentum before is going to be equal to the total momentum after. So this implies that the mass of the box times the initial velocity plus the mass of the ball. Okay, what can we say? We said crate, not box. then the mass of the ball times its initial velocity should be equal to the mass of the crate and final velocity plus the mass of the ball times its final velocity. Oh yeah, I can see there's a catch now. There is a catch. Before we get to this becomes, we still need to use this concept again to calculate the velocity. We can say also, we know that yeah, you see, I think that 6.2 is important. Therefore, I'm supposing that A to B would be what we are talking about there, the change in kinetic energy. You see, I'm trying to think, yeah, that should be the change in kinetic energy, because that would be the work done. Okay, all right, okay. Okay, so let's see. We know that mgh plus half mv squared should be equal to mgh at the top. So of course at the bottom this is 0 plus half of 0,5 v squared, or maybe we can say u squared, is equal to 0,5 times 9,8 times the height of 0,6, because that's the maximum height, meaning the kinetic energy is 0 there. So this implies that our u is going to be the square root, again, it's going to just be 2 times 9,8 times 0,6, because these ones will divide to 1, cross multiply the 2 and take the square root. So this is the velocity after collision. So we've got the square root of 2 into 9,8 into 0,6. So we get 3,429 meters per second to the left. Okay, so once we do that, that's the velocity after collision. We can say therefore the velocity of ball after collision with the crate is equal to 3,429 meters per second to the left. Okay, that's what we are looking to say and to do, because we will be getting stuck here. So we continue now. Mass of the crate is 1,5 times 0 plus mass of the box is 0,5 times that velocity of 3,29. This is before collision, so it's going to be that velocity before collision, which was 6,261. is equal to the mass of the crate is 1,5 times the velocity plus 0,5 times 3,429. Okay, So we can say therefore the velocity of the crate is going to be all of what we see there, which is 0,5 into 6,261. We subtract 0,5 into 3,429. We then divide all of that by 1,5. Of course, guys, I feel overwhelmed a bit, so things may not go so well here in this calculation, I have a feeling. But at this point, it's not about me getting it right, it's about showing the proper approach to a student who is probably not so sure of what is necessary. With the hope, of course, that all of this demonstration will assist that particular student to get things right. Again, the question said speed, so the direction is not necessary. So this is not a big question otherwise, but it's one of those questions that force us to, to do the things that need to be done. As you can see, it's a multi-step calculation. So we can say, well, formula, and we need this answer, 2 marks, and this time around we get this answer, 3rd mark. A different formula here of momentum, 1, 2, 3, 4, 5. Okay, it's not a big deal. I think so. I think our answers are correct. Either way, guys, the 5 marks is scored. So if the answer is coming up nicely, we would get, instead of 10 marks, this would be 7 now, because that question has been messed with. So, yep, that's it. Question 7, work energy theorem. Big question in physics, guys, and the mechanics. So please know it well. In the diagram below, a small object of mass 2 kilograms is sliding at a velocity of 1,5 meters per second down a rough plane inclined at 10 degrees to the horizontal. So this means this thing is decelerating, perhaps. I don't know. We'll see. Now we're told that at the bottom of the plane, the object continues sliding onto the rough horizontal surface as well, and eventually comes to a stop. So we know that at C, the final velocity is 0. Okay. The frictional force acting on the block while it slides along the inclined plane is 2,5 newtons. So that's good. The coefficient of kinetic friction between the object and the surface is the same for both the inclined surface and the horizontal surface. Okay, this is somewhat a strange question. Again, this is suggesting we're going to have to deal with some issues here. So let's quickly run through these questions. Define the term non-conservative force. Again, guys, definitions cannot be overly emphasized. We can say it is a force whose work done on an object depends on the path taken. All right. Not a very complex definition. It's all about, it is a force whose work done, potent, depends on the path taken. Right. So 7.2, we need to draw a labeled free body diagram of all the forces acting on the block while it is on the inclined surface. Alright, on the incline, let's say this is our incline over here. We'll say, okay, there is our object. Perpendicular to the surface, we're going to have the normal force. Capital letter is good. And straight down, it's going to be the gravitational force. This is good enough. And then we've got frictional force against this motion. So since this is a moving object, we call this one Fk. That symbol is acceptable. So we only have 3 marks here. This was just to get the incline. Okay, each one of these gets a mark. You don't need to write this in full. But if you wrote any other symbols that we don't recognize, then, only then, are you expected to give a full account, whether in a form of a key or writing these in full. 7.3 says, state the work energy theorem. In words, we know that the total work done on an object is equal to that object's change in kinetic energy. Okay, so again, just to remember, this is what you just describe as you see it. So you can see that the definitions are actually provided in the formula sheet. Yeah, most of them are provided. So you want to tell me that you failed to copy, guys? 7.4 says, use energy principles to calculate. So this means we are restricted to this now. Okay, so 7.4.1. We need to find the speed of the block at the bottom of the incline. Okay, no problem. No problem. So we know and understand that. Wait a minute. Before we say a lot, do we have enough info? We can find the resultant force, right? We can find the resultant force here because the only 2 forces acting horizontally on this block is going to be the parallel component of the weight and the frictional force. Okay, so those are the only 2 forces acting on our lovely block, technically. So we just need the resultant of these forces. Right, but now what is it going to help me with this thing? Ingisiza kuphi? Ingiseda kuphi? Okay, remember we can use work done by non-conservative force here instead, because to find the resultant force, oh yes, we know that this is directly perpendicular, so we can actually work out that displacement here. We need to work out that displacement. This is sine 10, because we will need that, because I'm seeing the fact that we need to use energy principles here. So that's what we need to do. Or simply just do work done by a non-conservative force, because the change in kinetic energy is just going to give us that. And if we get that, then we can calculate the velocity at the bottom, because we're supposed to use energy principles. So let's use that issue there. We know that work done, by the way, the W is good by non-conservative force, in this case friction, is going to be, the change in the potential energy plus the change in kinetic energy. Right? Right. So we know that this implies, now, any work done on an object is actually a change in its kinetic energy. Ish. Yeah, this question is terrorizing me, but I'm gonna find a way. It's gonna work. So let's see, the work done is gonna be the frictional force times delta x cos theta, which is going to be equal to mg final height minus initial height plus half m final velocity squared minus initial velocity squared. Okay, so we know a lot. So the frictional force here is 2,5. Now the delta x here, we know that sine theta is going to be the 5, which is the opposite over the hypotenuse. And so we know the hypotenuse is going to be equal to 5 over sine 10 degrees. So I'm just going to put that one. I don't have time now. If you don't get it, you don't get it. Of course, now this is 180 degrees because the angle, friction is always opposing the motion. So this is going to be, what was the mass here? 2 kilograms times 9,8 times the initial height. The final height is 0, right? The initial height is 5. Okay? Plus half of 2 times the final velocity squared minus the initial velocity squared. Ooh. Okay, maybe let's move everything a little bit to the left, see. All right, so this is the story. Tiring. Ngifuna ukubhala. Hayi ke ngiyangijakelwa ke manje. Isiyangijakelwa ke manje. All right, so let's finish up. Now we have our business cut out nicely for us. So let's see, we've got 2,5 into 5 divided by the sine of 10. Okay, guys, this is quite a complex calculation, but hey, I will ask you, so this becomes minus 1 basically, the cos of 180. So let's see, what do we get there? I'm trying to think, what gymnastics can we put forward here to get our business done nicely? Okay, we can say, well, V is equal to we're going to have to transpose this and divide by that. So that's effectively 1. So this one is as good as 1, so it's gone. We don't worry about it. 2,5 into 10 go 5 over sine 10 degrees times minus 1. Then we subtract 2 into 9,8 into 0 minus 5. And then, after this has been said and done, we then add 1,5 squared. And we take the square root of all of this. Yeah, it looks right to me. It looks right to me. Of course, guys, I'm just trying to avoid too many rounding offs that are going to drive me crazy. So we've got 2,5 into 5 divided by sine 10. Just be careful with the brackets here. Minus 1 minus 2 into 9,8 into 0 minus 5, just as you see it, guys. Don't panic. This thing is going to work, okay? It should work. Yeah, so I'm getting a 5,32 meters per second. Now speed is a vector, is a scalar quantity. At this point, we don't want to worry about the direction because it's a bit controversial. We're going to say downslope or straight forward. We don't know. So leave it. And we can. All right. Because, we could still do work done by a resultant force here. We could still do it. I just decided to park this one. And I decided to use the non-conservative force. But for the sake of those who want to know if we're going to get the same answer, because this is a discussion, guys. We're not really chasing, the end of the video. Take it as a formal, class where you need to understand your stuff and to do it well, as opposed to just getting answers. Again, you've got options, guys. There's plenty of other channels that actually walk through these answers much faster and quicker, and you might just go there. But just be careful not to have your time wasted to thinking you know what needs to be done. It's easy to watch someone work, but if you don't fully understand their actions, it's a different story. This is why when I take you through questions, I go back to basics and I also ask basic questions so that you don't just answer, guys. You make sure you understand your actions, not necessarily to think, I'm going to remember this is what needs to be done. Do you ever know when, under what circumstances do you do what you do? Anyway, whatever, guys, marks are to be scored here. This is a calculation. Yeah, there's just too many things, guys, and it's just 5 marks. I'm worried. Yeah. This is a calculation on its own, and this is a calculation, okay? So yeah, easy 5 marks, no issues. The rest, substitutions are weak anyway. So sometimes you get marks, sometimes you don't, depending on the complexity of the question. But now let's see if we use the resultant force as we have proposed above. So we've got our box here with two forces acting primarily responsible for its motion. We're going to have Fk here, and we have our Fg parallel essentially, and it is itself 2 kilograms. Now, we know that work done by a resultant force is equal to, sometimes I hate this word net. In fact, I'm going to start not writing it. Don't be like me. Hey, it is all faffy. So do not write the things you see me do sometimes. Hey, unless you know you are brave. And of course, if you get victimized, call me. You have my number on the channel. Call me. I'll take anyone to task for you. Believe me, I will. Just try me, you will see. I can cause a stay if I choose to. So, besides, I'm dramatic. You know, Dan Final Bandi, the actor. Excuse me, guys. My throat is dry now from talking. Right, so the resultant force times delta x cos of theta equals, we know the final velocity squared minus initial velocity squared. Now what is the resultant force here? Is Fg parallel. So Fg parallel here is basically mass, which is 29.8, and this is sine theta, right? Because we say Fg parallel, if we draw the components of weight like here, it's going to be the gravitational force straight down as the resultant force, and we know we're going to have the parallel component going in that direction. So this is how the parallel component is going, and we're going to have a bad place to show this, and of course we're going to have the normal force there, and the normal force is balanced by the perpendicular component of the weight, and the parallel component goes like that, and that's the angle, and then that's the 10 degrees. So when we look for this, that's the opposite side to 10 degrees. Can you see? That's Fg parallel, whereas this is Fg perpendicular. Alright, so that is the story. So it's going to be mg sine theta. Right, we subtract because we're moving down the frictional force, which is 2,5. Then delta x is going to force us to use trigonometry as well. We know that sine of 10 degrees here is going to be the opposite 5 over AB. So in essence, AB is going to be 5 divided by sine 10 degrees. So at this stage, sekulinyelwe sesilimele sinaxesha lokujustify. So this is 5 divided by sine 10 degrees. Now, of course, remember, the resultant force is going to follow the bigger force, so it's going to be downslope. So it's acting at 0 degrees. Right, so this is a half of 2 into v squared minus 1 comma 5 squared. Alright, so this one is doing the things too. Is doing the things. So we already know that this and that is going to go. So we know that v is going to be the square root of this left hand side, 2 times 9 comma 8 sine 10, right, minus 2 comma 5. This is all multiplied by 5 divided by sine 10 degrees times cos of 0 degrees, and we just add the 1 comma 5 squared. If we don't get the same answer, please, madam, I deserve to die for misleading the nation. 2 times 9 comma 8 times the sine of 10 degrees. Then that is multiplied to 5 over sine. See, these calculators, man, are beautiful. We're never allowed to use a calculator like this. But you know what? It's like my brother, my parents, let me say my parents. Like my parents knew that the Gersha is the future, man. Back in the days, the DAL, the sharp DAL was the calculator. But of course, ones that could do what these calculators can do were not encouraged. But instead, they bought me a Casio. Hey man, that thing was powerful too, though. It actually was more powerful than that DAL. Turned out, swa. You see. Those are the things, Buffett. Those are the things. Aye. Bavele bayibona nje kai bayikho lento lena. Casio is the one. And it is indeed the one. Hayi ngoku. Nokushaya amanzi. Sekukhona ukushaya amanzi. Sekukhona ukushaya amanzi. Maningaqhelwa kabi ke ngoku. Ngathi sendiyaqhelwa nje. Oh, well, I forgot to subtract the 2.5 mos. Yeah, man, I was wondering now, what is this thing? What is this thing doing to me there? So minus 2.5, yo, bese nifuna ukuqhuleka ndifisiqaqa. Yabona, batla ho mpolaya. Now ka shimpolaya mos, ukena. I'm not the dying type, must you see. I'm those people who just don't die. They are the people who live forever. So again, that is the speed, so we don't care about direction. Can you see? It's coming out. So my brother from another mother, you must be impressed if not impressed. But even if you are not, I don't care. I'm one of those people who have a very high self-esteem, you see. I believe in myself even when people don't believe in me. Yeah. But at the same time, I don't get a stinking attitude of ignoring the environment because what it has to say about me. It's truly an observation that I should be worried about if it is bad. But at the same time, knowing very well that there can be, some incorrect assessments and examinations of issues. What appears to be sometimes is not, So yeah. Formula, we got a mark, but for to calculating this one is a mark, and to find the resultant force, you can say the left-hand side as a whole, that's a mark, and the right-hand side as a whole, that's a mark. 1, 2, 3, 4. Final answer. The gymnastics, guys, are your problem. Please, man, you must know these things. Now let's do the last question here. Do we have enough space? Yes, we do. We can even make it nice according to the instructions. Now the distance BC, we need to calculate the distance BC that the block moves before it comes to rest. Again, we are to use things there. So we know that, okay, our box is still moving in that direction and some friction is opposing it. But now what is the force this time around? Sunlilis. AP force kanin. Okay, all right. I think our job is to find the frictional force here, because this one is osibulalisa, asikwazi ukuyifumana. Now we're going to use the non-conservative force here, because it's only friction acting actually, because the vertical force is gravity and the surface giving us the normal force are going to be zero. So they are not doing any work because they are perpendicular to the movement. So this takes us back. As you can see, voila, this already suggests the examiners had this approach in mind. So that here we use non-conservative forces for the second one. But there's nothing wrong in doing it that way as well. Alright, so we know that the work done by a non-conservative force is going to be the change of this kinetic energy, potential energy, plus the change in the kinetic energy. Right. But we were told something here about the friction on the surface, that it is the same as on the inclined plane. So this is a very jam-packed question. Come on, easy though, guys. You know how to examine. Spare that you are careless at being meticulous, at making sure the question paper is error-free. You need to sort that out, guys. I put you on top. I'm sorry, but I do. You guys know how to examine. That's just one thing I can say about you. You know how to examine fairly, and students fail if they want to fail. They pass if they need to pass. They want to pass. But you don't find so much of the examiner trying to be too much for the students. I don't find it. But it just tests what students should know, and within their logical, realm or domain. Yeah, man. As beautiful, this thing, man, is moi. Yeah, man, come so, man. Yay. I must not beg, you must. I'm telling you. And you're gonna do it. Alright. Nonsense aside, what are we going to plan to do here, guys? We need to find our frictional force. So we know that this is frictional force times delta x times the cos of theta equals mg, the final height minus the initial height, plus half mass, final velocity squared minus the initial velocity squared. Now what is frictional force? Frictional force, we know from the definition we just dealt with above, is the mu k times the normal force. But now what is the normal force here? The normal force is equal to mg because these two are balanced. Sishayile, so sesishota nge-coefficient. But ke ngokwe-coefficient siyixelelwe into yokubana iyalingana nalapha ngenhla, which means the surface siyafana ke. In a way, it's a type of the surface that is the same, yabo. Ke ngoku masike siyicinge ke bese uyifumana kanjani? We know besike sabhayiza pha eqaleni sathi hayi man, le nto lena ibiza by frictional force. sihlanganise normal force kanje ratio kanje yona iyodwa. Kamnandi siyamazi ubhutiza, siyamazi nosisiza. Ayifumana ke ngoku. Yeah. Unganibuza why ndithi ngibhutiza lwa. Ndithi ngisisiza lwa. Ndichilo qha. Ngazonibuza izinto ezisnacks. So the friction of the kinetic friction here is mu k, which is going to be the friction above, which is going to be 2,5 divided by the normal force here is equal to Fg perpendicular, because the normal force is equal to Fg perpendicular, because those are the perpendicular forces to the surface. All right, so let's start there. What is the Fg perpendicular here? It's going to be 2 times 9,8 times the cos of 10 degrees. So guys, move fast. Delta x is what we are looking for. Now cos is 180 because friction always opposing the motion forward. So this is 2 times 9,8. Now this one, the change in this is literally 0 because there's no height anymore. Umponi hore ke tla le yona jwale. Ihlile ke tlile le yona he ngwaneso. O ibone hantle he le wena. Rai, ke a lwana jwale. Ke lwantwa. Ke a ntwe. Bakeng tsa mafa le mabidiko. Acha bafana ha ba ithoka he mahae mane. Empa ke lebetsa re ba reng hantle pele ba re ha ke a theng, hana ha ke a reng. Ha ke a nna ke a ntwe. Bakeng tsa mafa le mabidiko e. Hebana re the mabitso. Laka la bana se ke iteile. Kena marena physical science. Re tlo kopana ka di work energy theorems in the exams. How about show ba mokokotlo? Asian fits. Into ezimnandi. I used to enjoy my life in the villages, man. It's boring in the towns. It's really boring. But if only one could live in the villages, at a level of a socio-economic status of being in the townships, there would be no one going to the townships. I swear to God, the economy would collapse in the big cities. But hey, yeah, it is what it is. Okay, so what was the velocity now, guys? It's that velocity we calculated. You see that velocity at the bottom there? That's becoming our initial. The final is 0. Minus the initial becomes that 5,32. Oh, wow. 18 nangoku yasikhafuna unisokolisa. Andibani nento ezinisokolisayo ke tana. Ndizonda ukufa into ezinisokolisayo. Ngoba andisokolisi into njalo nje. Kanene besifuna x andithi bese sizomfumana ke ngoku. So ithi into ke ngoku delta x ke yena usala engubani. Kuba ngilomcimbi umde. In fact ngu0 yonke lento le. Leyo nase siyayidropa nje. Yeah, siyayehlisa ngoba ngu0 qanda qox so ngu0,5. Nayo le asike sithi uyidibanisa nje sihle amahlungwana phezulu ingekasimoshi imkile nayo le gone. Yabona into seyisele ngoku apha qha. Hey yabona ufuna ukuthini ngoku? Sekuselelo kuyeyedwa onokundi thani kuyeyedwa onamandla kutsho njalo hayi kuyeyedwa onokubongwa itsho kuyeyedwa onokubongwa kuyeyedwa onokubongwa kuyeyedwa onokubongwa kuyeyedwa onokubongwa malibongwe igama lakhe malibongwe igama lakhe ndiyakwazi ubhesa bawedina ne-week bafana bam ngidinga ukutshaya icuba nini ukuze ndikwazi ukubhesa you buggerers ngikwazi ubhesa ningatshayanga rabarasta destere bekhala bakhara eish siyabona ukudlala ngabantwana babantu but andiwake makwede ningakhonyi phaa ekuhlaleni ndizonihlanyisa dibani nento ezikhona zingakwazi ukuma siqhathise andikwazi ukuqhathisa nina ngigcwele njengolozana phofu niyifunda phi ke kwezi zidenge zizibiza ngoosopolitiko okubhuti benu notata benu because ke abanye babo shem bayandicaphukisa sorry to say it kodwa funeka niyazi loo nto injalo ningazothi ngomso xa sendiyithethe sendingayilindelanga nindibhayizela apha nindixelele besicimba ngumntu nice mos kanti wena ngumntu esisidom kanti dom kophi mos ya mos ndidom mna ndazalwa ndiyidom I am proudly dumb and I will die dumb because being dumb is the thing. Hey, yabona son, wenze ntoni apha kanye kanye? Oh hayi kanene, it's a different question leya iphezulu. Sendifuna uhlanya, ndiyekeni. Okay, masingathi siyayiconclude. Sendidiniwe yazi guys. I didn't think I'm gonna take so long though. Kodwa ke, teaching is not pap and vleis mos. You don't just sit at the table and eat. It's nie pap and vleis daai ding. It's werk hierso. It's werk daai ding. You must work mos. You must work. You must work. You don't work. Asozibe ngumngani wami. Olivia. Kasondela nokusondela cala ngam zandibangela isitshisi. Andibangela isifuthufutu. Uzawujuluka ngenxa yakho. Uzanditshisisa ngobuvila. Buyatshisa ndixelele baba ungayazi loo nto leyo. Ubuvila buyatshisa be, butshisa isicefu. Ya, noyisa makhwaba. Make ngifuna ubona uba ndisubstitute kakuhle naxolweni guys. Eish. Lo bhuti lona wavela waba nomlomo omkhulu ngoku umncinci. Kodwa xa ungazijonga ke tani lips zam zinkulu ziyatsho vele uba yeyi. Fanele ndizibethekise enye kwenye. Andikwazi uziyeka zithuliwe kungathi zidumbile ke ngoku yabona ingathi ndibethiwe. So hayi. Ndizibethekise kubeka. Right. Yo, ayisenkulu andiyithembanga tu ke le answer. Kodwa ke it is what it is. So I'm getting 5.1 meters. Ayiziyakhala. Esikhala kakhulu. I don't know ke guys, ngenzeka uba ke ndibhale zomqalama apha okanye ndibhale zomqalama andazi nani nizozibonela. Nani senizozibonela. Yayibona. Okusalayo ndinibonisile i-approach. Ndiyanicela ke ngoku niqwalasele yonke le nto endiyenzile. Uba ngabe right, kodwa it's convincing to me. It's just that the value is big. Kodwa ke, I am convinced, guys. I am 100% convinced. So, yabona ke ndiyicingile le nto hayiyo nje. Silibele i-normal force. Yawena ndiqondile bikhona into engekho manapha. Khona ityiwe elahlekileyo because this was just the coefficient of kinetic friction. Yeah, man. I could tell something is missing. Alright, masiyisolve ke fact yonke le ayisekho right xa nje. Phofu ke into elahlekile into esizoyimultiplya kwalapha ezantsi, so asingabisayisula le i-answer kuphela masiyosule. Into emasiyosule apha actually ndifuna ukuyinciphisa le nto ndizokwazi ukufaka le ndiyidingayo. Superb yakhe aske watatazela nje. Yabona siqhele. Simtholile onokubongwa, simtholile onokubongwa kuye yedwa. We were supposed to multiply by the normal force. This time the normal force is the gravitational force, as we stated here. So this is going to be 2 times 9,8. Yeah. Phelele ke ngoku. Yabona ke ngoku sesiyahamba ke ngoku. Iske yankulu man, ndenza ndaqonda man kunuka ifish ngoku. Nuka ifish engaphekwanga bathi isushi xa bezibiza izinto zezi-snacks abazidlayo abafana basemzantsi. Hayi nina niyazithanda izinto. Bukela abantu bale empuma betya into ezi-snacks. Nani seniyaxhofuza ngoba ndicinga uba kukubhadla ukwenza loo nto. Uba dom man ukwenza loo nto. Hayi nina maze nidle netyhefu ngenxa yoba wonke umntu uyitya kamnandi. Hayi man, kaniyeke man. Nazi neziyobisi zafika nisazi ngazo. Aninoxoka nithi naningazi ngeziyobisi. You knew about drugs and how bad they are to life, but you guys still smoke them anyway because you see people smoking it and claiming to be having a time of their life. You always copy crazy things, folks. I don't understand. Kind of people are like this now, who have all of a sudden lost their pride. Huh? You guys have lost your pride as the people. Imaki, khona into endingayifumani kwenzeka ntoni apha. Theni ngathi man sikanketsa latha wena man. Walon antso umpotapotisa kanqina jwalo nketsana. How? Papala ka nna jwalo. Ha re no utlwana he. Re tlo qabana. Tlo fa mathata, haeba o batla mathata. O re mfanone. Are ke tlo fa mimi. Wahana. Ke tlo fa mimi. Fana ba tella wa tseba. Ke dintho tsena tse hotseng di sa fumane molamo. Jwale ha di tsebe hore ha o bue le ba ka jwang le ba bang batho. Jwale di bua ka di bua le dithaka tsa tsona kampa le batho ba ba tsebang. Le tlo ifumana phafa bafana ba ka. Nako ya lona yatla. Ke a le tshepisa. It's still big man. Yo. Hey. Wena. Kanti into ngale we. It's still big like yo 111. Hey guys, nizobona nani banikhanda kuphi khona la esingathi ufuna ukubhayisisa khona. Intenza ndingaqonde man, ngiyabelayela jwale. Hey gafethu, theni kodwa le mpendulo iniphathe kakubi nje. Iniphethe kakubi le mpendulo man. You know. Kutheni izoba nkulu kangaka? 11. Hayi guys, ncinci kaloku ezi forces ezilapha. Yabona ke ngoku kanti into endingayiboni endingekho sure ngayo. andisekho sure ngale nto endiyenze apha guys, yabona ngoku. Hayi khona khathele ke ngoku, kathi yintoni ngoku? Isingilengile ke manje, singilenge laa way yasemdantsane yabo. Njenze ntoni ngoku apha kanti? Oh, kulibeleke u-cos theta. Oh God, give me a break. Yeah, doch. Ayya. Yo, Nkosi yami. Uyanibulala ngoku. You're killing me. Dilibele u-cos 10 degrees phaya. Yes. Okay, mhlawumbi izoyilungisa ke ngoku. Hayi, if ayilungi. Noko man inkulu kodwa le nto ikwazi uba kwi-hundreds guys. You can see it, man. The frictional force acting is small. Even those velocities, we cannot have this in the triple digits. It should be double digit answer, man. Khawuthi sibuye kancane. That is not just 2 times 9,8. That's just the weight. Then we need to say times. Oh, I even wrote 98. That's why. 9,8. I don't know what did I write here, guys. 2 times 9,8. Hayi, ndowada le peduli yevele yaphambana ndinibhale into eninzi erongo times the cos of 10. Okay. If we don't get double digits, I give up, guys. Okay, get double digits now. I can accept finally. This is 11,32. You see, I did the wrong thing, so don't do what I did. As you can see, there's a lot of things missing as a result, but I get tired of writing too many things too. So I just want to force you guys to also refine how you present your answers, to do certain things within the same structure. Nobody's going to force you to say it. You know, as long as it's there, the answer is right, it's good. So we get a mark there. This kinetic coefficient gets a mark, and the whole left-hand side gets a mark. The right-hand side, we get a mark. So 1, 2, 3, 4, 5. It's a scalar quantity, this thing. So maybe we can even do the things that needs to be done and say therefore BC. Alright guys, so yay, hayi ke ngoku sekuthatheke ixesha elibhaya blind. Kodwa ke, I need to show you things, guys. I need to show you things. Right. We move. Ayogqibela le yey wena. Zininzi most of these questions, yo. Let's move. Hey, the siren of a fire truck moving at a constant speed of 20 meters per second along a straight horizontal road emits sound with a wavelength of 0.34 meters. A detector on the same road records the sound waves from the truck with a lower frequency than the sound emitted by the siren. Keyword, lower frequency. So if it is lower, then it means this fire truck is moving away from the detector. Right, take the speed of sound in air as 340. Even if it's not stated, we should take it as such. Define the Doppler effect, guys. We jump because it is better way. So 8.1. Okay, bookwork 8.2. Is the fire truck moving towards? It's moving away. Give a reason. You can say that it registers. Okay, it registers a lower sound frequency than actually emitted. All right. So it's as simple as that. So the answer is right there. Okay, so away, and the explanation, it doesn't have to be too fancy anyway. 8.3, it says explain in terms of wave motion why the detector records sound waves with lower frequency. Explain. It says explain. Hey, this one is crazy. We know that while v, the velocity of any wave in the medium, is frequency times lambda, wavelength. So we can say this implies that the frequency is inversely proportional to the wavelength. Okay, you can say it in words, you can say it in symbols, because we're told to explain. Yeah, and so that means Mark 10 Mozambuza into a 1. You stated it. Okay, question itheni ngathi ufuna undistopha ngoku bengxamile ngoku ingathi ufuna ukundicotisa bengafuni ucotha, so yandicothisa ngenkani. Explain in terms of wave motion by the detector. So why the detector records sound waves with lower frequency. Oh, I see. It's not about this per se. Wow, almost caught me. Pants down. We can say, well, as the sound is emitted by a car, there will be lesser compressions behind the car than there are in front of the car. Or we'll say there will be lesser particles arriving at the detector. Okay, I can just say, as the car moves away from the detector, there will be less compressions behind the car. Okay, there will be lesser compressions behind, let's say lesser compressions behind the car arriving at the detector, such that the wavelength appears to be longer. We can say since V is equal to the wavelength is inversely proportional to the frequency of sound. Hence, the frequency will be lower. It's actually a higher grade question because, see, sometimes you get an idea from just bumping into the wrong thing. Okay, the right thing, but the wrong way. And then you start to think, oh, hold on. First, we need to explain how we end up with a longer wavelength. So as this car is moving ahead, there will be more compressions in front and less compressions behind. Maybe we may even add that part, but I think we need the part of the, wider wavelength or a longer wavelength. So we'll say now, as the car moves away from the detector, there will be lesser compressions behind the car arriving at the detector, such that, not such there, such that, read what you write as well, such that the wavelength appears to be longer. This is key. And it appears, by the way, it's not exactly longer, it just appears to be. Right. Now, since this is the equation, the general wave equation, the wavelength is inversely proportional to the frequency of sound. Here goes, yeah. Since this is the equation, the wavelength is inversely proportional to the frequency of sound. Hence, the frequency will be lower with a wider wavelength. Try to make sure statements are as complete as possible, folks. Either way, we have done justice here. We should be getting our marks, okay? I think talking about the number of compressions arriving at the detector, that should be a mark. And when we talk about a wider wavelength, that should be good. When we talk about the proportionality of the two according to the equation, that sums it all up, okay? Right. That was a low-key killer. I didn't see it coming, okay? Calculate, right, the frequency of the siren. So 8.4.1, we know the velocity is equal to, by the way, we're looking for the frequency of the siren, yes. V is equal to like this. Right. So this is 340. Frequency, we were given the wavelength. Therefore, our frequency is going to be 340 divided by 0.34. Right, so this is 340 divided by 0.34. So we get 8,000 hertz. Please correct. Don'ts. So standard 3 marks there. 8.4.2, we need the frequency recorded by the detector. So we want the frequency of the listener. So we know that frequency of the listener is V plus or minus VL divided by V plus or minus Vs times the frequency of the source. So this implies that the frequency of the listener is going to be 340. Now, we know that this detector, we're not told anything about it, so it's essentially, wherever it is. So we know this is 340. Now remember, we want to get less. So that means our denominator has to be bigger. Now, so what was the velocity there? It's 20. Then we have the frequency here, which is what we calculated. So we can say therefore the frequency of the listener is, I wonder why is this 6 marks though? Anyway, let's deal with it. It's going to be 340 plus 20. Sometimes when this is giving too many marks, it means the marks are within the detail rather than the actual gymnastic as a whole. So we can see that from 1,000, we hear 944,44 hertz. Okay, easy stuff. So we can see that it's lower indeed. So first and foremost, we get a mark for this. We get a mark for adding here. Right. And then, I will guys, 6 marks value. Hey. Yabona ke ngoku andisayiqondi ke ngoku. Nifuna ungixelele inzima le question? Hey guys, what is going on now? 6 marks? Are you kidding me? This is not right. I don't know guys, but again, this is one of those issues because we can say we get a mark for adding here. Maybe we can say general substitutions. This for me is a 4-mark question, not 6. So I don't know where the 6th mark comes from. Anyway, let's move on. We know that these provincial papers are disappointing big time with these errors in them. Sometimes certain pieces of information are given but not written, and then all of a sudden the whole thing is different, and you can see nobody checks these things. Oh, man. You're spoiling my mood. Now we need the speed. Okay, the speed of the fire truck has now increased to 25 meters per second. How will the increase in the speed affect the following? Again, this is higher grade stuff, guys. Very good questions. Always, there will always be something, especially in the finals and the final exams as well as the supplementary exams. There's always very interesting questions there. Usually the trials, there may not be so much, but there might be some areas where there's kinds of interpretation, because this is now the synthesis of it all. Right, I please don't want to be hearing the word explain. I don't have the time. Thank you, God, for being kind. I no longer need to think about explaining my choice. It says now the speed of the fire truck is increased, right? How will the increase in the speed affect the following? So choose increase, decrease stays the same. The frequency of the sound waves emitted by the siren. Remember, these ones are actually constant, so they remain the same. So we write stays same, because that, no matter how fast it is, the frequency of emission is not going to change. 8.5.2. the frequency of the sound waves recorded by the detector. As you can see, if we increase on this denominator, it becomes bigger and bigger. And that means this one becomes lesser and lesser. So it decreases. Okay. Again, easy. Nice and easy, nice and easy, nice and easy. These were just explanations there. They are not supposed to be there, okay? But in this memo, they are there. Because this memo would make more sense when the student looks at it using the video as well for the lesson. All right, guys, I don't know why there's a 6 marks there. I doubt it is a 6 marks because this question is not complex. It's definitely not complex. Unless somebody wants to tell me that this detector was also moving, then we may have had to stop one, which can add the extra 2 marks. If we only stop the other one, we could stop the other one as well. You see? Unless really there's that scenario here, I don't see why it should be 6 marks. Either way, guys, we can safely say this is just 14 marks. The extra 2 marks, we don't know where they come from. Yes. Right. Last question, guys. Yo. Hibo. Let's leave this one for some notes for those who want to play along. I didn't think I was going to take so long. But again, I got relaxed, I guess. Okay, QA and QB are metal charged spheres. QA is placed on an insulated stand, right? While QB hangs from a ceiling by means of an inextensible string that makes an angle of 25 degrees to the vertical as shown in the diagram below. If I may ask, why insulation? We want to create a closed system. Or should we say an isolated system? Because we don't want the energy here, which is the charge, to be influenced by other things. So perhaps an isolated system rather. Okay, so while QB hangs, okay, that's it. We read that. We're told QA carries a charge of 15 nanocoulombs. While QB has a mass of 6 times 10 to the 5 kilograms, okay, and carries an unknown charge. Now QB is in equilibrium. Very nice questions. Otherwise, EC, please, man, just do the right thing and make sure these things are properly checked and that all that needs to be rectified is rectified. These are good questions. I promise you, any students who walk through this page, this question paper, will even start to feel like they understand the rest of the topic, because this examines the most of each topic in a very nice way. Right, okay, maybe I'm biased again because I'm from the EC. Okay, all right, okay, it's fine. Now, let's look and see what I'm going to do here. It says, is the net charge on QB positive or negative? And give a reason for your answer. Very interesting. Is interessante. Interesting stuff. Is it possible to decipher that? Angazi kanjani. But remember, let's just imagine now, this is already positive. Let's say this was negative. What was going to happen? Oops. They would kiss. Only after kissing, then we would see something going up. But again, let's just say they were initially not the same. Then they kissed, and then after they kissed, they are going to carry the same charge. whether positive or negative. At this stage, once we see that this is positive, it means this one must also be positive. Right. So this is 9,1. We're going to say it's positive. Give a reason. You can just say like charges repel each other. So to maintain that distance between them. Ne? Or else they would just attract until they come together, and whatever happens thereafter. So even if they did it before, but at this stage they are certainly like charges, otherwise they would not sit like that. The other one would be in motion, depending on whichever is fixed. But of course this is the fixed one, so this one is unlikely to move, but this one is mobile. All right, so very interesting question. Again, it's a low-key killer with just a basic explanation, but you wouldn't think about it, would you? 9.2, so think critically, guys. State Coulomb's law in words. Again, guys, is on board. Textbook, guys. Textbook, or study guide. And I know someone is going to say exam guidelines. Exam guidelines, they say so. Well, I don't have a problem with that. But my only problem is the fact that it seems teachers are saying the definition should only come out from there, and that's ridiculous. Why do they prescribe textbooks then? Why don't you just get exam guidelines in schools and only have them? Sometimes. And in this taking with the pride of a frog, you will best tell you. Anyway, leave that one. Calculate the tension in the string. So you want the tension is 4 marks. Of course, guys, we need to work on our diagram before we can do that. We know that if they repel, this one is getting the force going in that direction. So this is the electrostatic force of A on B. But there's gravitational force pulling that charge down. So we know that it's going to have its Fg. Right, and of course there's going to be then the tension in that direction. And if we are at equilibrium, we can shift these forces and shift our tension to come up here. So that becomes the tension, and then we shift our gravitational force to come down there. That becomes our Fg, and the angle here is 90 degrees. Then we have a nice triangle to work with now. You see, creativity. So this was asked in the MCQs, and it's coming back when you least expect it in a different format. Now the question would be, what is the angle of the tension with the vertical? Yes. Why is the 25 degrees coming here? These are going to be alternate angles, isn't it? Because this is a continuation of that line down here. Then that and that are parallel. So these are alternate angles. So we say 9.3.1. Our matters are like SWA. sesiyibetha ngalaa ndlela esiyifumene ngayo. So sesiyishaya sibe sesiyayikhapha, siyibetha size siyileqe ngoku. Sesiyayibonisa uba asiyisabi. And i-arrows afuneka zihambe zijonge endaweni. Xa zinje, that's equilibrium. But xa zinje, for example, you know, this becomes the resultant. But here there's no resultant, it's zero. Everything is the equilibrium of the other two. Right. So this is not the case. So the arrows are going differently. Now that's the only difference with this one and the one in the MCQs. Okay, right. So we know that this angle is 25 degrees. We're not going to justify it. We know it. So this is FG, which is going to be mass. We were given the mass here. This is 6 times 10 to the 5. Is it minus 5? Minus 5 to the minus 5 times 9,8. What is this equal to? 6 times 10 to the minus 5 times 9,8 gives us a 5,88 times 10 to the minus 4 kilograms. Not yoga, newtons. Down. That's the one. And we know that the distance between them is this one, which we need to convert to meters. So 50 divided by 8,000 is going to give us 0,05 meters. So we need to think about that. So this means, since we don't know this electrostatic force, we're going to have to think about using that, because, yeah, it's doing the things. But the tension, we don't need that force for the tension. Okay, so we know that, okay, using our stuff here, maybe let's move it aside a bit. It's going to start crowding our calculations. So we will see that cos of 25 degrees is going to be the FG divided by the tension, hypotenuse. This implies that essentially the tension is going to be FG, so this is 6 times 10 to the minus 5 times 9,8 divided by the cos of 25 degrees. Therefore, the tension is equal to 6 times 10 to the minus 5 times 9,8 divided by the cos of 25 degrees. So we get a 6,49 times 10 to the minus 4 newtons. Now remember, guys, the question said tension on the string, so there is a catch here. We need to find the direction. So the direction is at what direction here? We follow the north-south compass business. So the north is at 0 degrees. South is at 180 degrees. Now here we're looking at 25 degrees to the west of north. So we can say that and say this is 25 degrees west of north. Or we can just do the degrees like so. See that this is the complement to this. The complement is going to be that angle. So just say 360 minus 25. It gives us 3. Okay, we can say at 335 degrees. Okay, of course one can still say this is 25 degrees north, west of east. Sorry, west of north, sorry. Or one can say from the north we go 25 degrees west. So these are the possibilities to give that direction there, but it has to come up. It has to come up. Right, so this is it, guys. 4 marks in the bag. So technically calculating mg, getting the answer, as well as the direction. So this mark is for the answer, correct unit and direction, right? Right. And of course defining a trig ratio, that's the formula in a way. And the sketch helps. Without it, we would not be making sense of what is going on. Right, so 9.3.2. We need the magnitude of the charge on B. Okay. So obviously, folks, we can calculate the electrostatic force here. Right, so we need the electrostatic force first, then we can do the tension. So we know that the electrostatic force on B, of A on B is going to be equal to K QA QB over R squared. So I'm going to chow this fast. So what is that electrostatic force? That's tangent, isn't it? Adjacent, opposite over adjacent. So opposite over adjacent over there is going to be FE over FG. That's going to be 1025. Now we are looking for this. So basically, this is going to be FG 1025 degrees. I'm just going to go for the jugular this time around. So this is going to be basically FG, this is 6 times 10 to the minus 5 times 9,8 times the tangent of 25 degrees is equal to, this is 9 times 10 to the 9. QA is 5 times 10 to the minus 9. Nanocoulombs means that, times QB, all divided by, so we do that 0.05 squared. So this implies that QB is going to be 6 times 10 to the minus 5 times 9,8, 10, 25 degrees times 0.05 squared, all divided by 9 times 10 to the 9 to 5 times 10 to the minus 9. Therefore, charge on B is going to be that. So this is basically 6 times 10 to the minus 5 times 9,8 times the tangent of 25 times 0.05 squared divided by 9 times 10 to the 9 to 5 times 10. So this is 15. Lord. Yabona ke ngoku sebenzeka Zemaputas. Okay, guys. isifuna ukungishaya manje. Ndiqondile banibalezo mqalami. There's something that's missing. Okay, let me start again. I've got here 6 times 10 to the minus 5, right? Times 9,8, ne? Times, let's just say 0,05, all squared, times the tangent of 25. Divided by 9 times 10 to the 9 into 15 times 10 to the minus 9. Yep. I knew there was going to be some dangerous actions. As you can see, this electrostatic section, guys, is the part that annoys the most, because there's just too many things. It's like financial maths in paper 1, mathematics. There's always complex formulas and substitutions and gymnastics with complex, terms. That's just the thing, but it doesn't mean it cannot be done. Just says maintain focus, guys. This is good. So calculating the electrostatic force according to our diagram, and we can say the general substitutions there, very important. So we've got 1, 2, 3, and then converting this to meters, and the answer, remember, we must have the correct magnitude with the correct unit, capital letter C. Right, so this is it, guys. Easy 5 marks. Nothing really out of the ordinary here. So let's do the last one. 5. It's not 5, it's 9. 0.3. Okay. We need the net electric field at point X. Can you see? This is the resultant. So this means we need this distance too. So this is what gives us this extra mark. So this one was already given is 20. So we need the other one. Okay. So we know that, okay, E total here, hate this net business, E total is going to be K QA over R squared plus K QB over R squared. But since these are vectors now, we will then have to consider the direction. Right. So this is going to be equal to 9 times 10 to the 9 into QA was 15 times 10 to the minus 9, all divided by, now the distance is going to be 50 minus 20, that's 30. So 30 divided by 1,000. But we can even show it, Say this is going to be 50 minus 20 divided by 8,000 squared minus, we're going to choose the opposite direction as negative. So this is 9 times 10 to the 9 into 5 times, 5,08 times 10 to the minus 9. All divided by, this one is going to be 0,02 squared. Usakundenzani boy. Ngingakusalila-ke ngoba ndithethe into ezininzi bafowethu, phela mina ngiyakhuluma. Ngelinye ixesha I become obnoxious, yabo. I'm not excusing it. I'm just telling you. So ungacingela uba yi-excuse, no. I wouldn't need an excuse, Mus. I know I'm a fool. And I am fool. So don't even try. I am a fool that is full. So don't waste your breath, okay? If you start talking to a fool like me, you're going to end up foolish yourself. So for your own sake, try not to be as foolish as I am. Be smarter than I am. You see? So we get 35,700. Remember, this is newtons per coulomb. But it seems like this is acceptable to say volts per meter. Right. Yeah. Or some people choose to write like this. Newtons times coulomb to the -1. Or this one is volts times meter to the -1. These are acceptable. But try to use this one, okay? This one is the one. Although you may not be punished if you use this one. But we did this when we were using parallel plates. Using the Millikan's experiment type of thing. So parallel plates. Parallel charged plates. We talk of volts per meter. But in this case, the right one is the other one. So again, we'll see Kibile Gabafonzi. Lengibathandzako engazi kahle ukuthi nabo bayangithanda bangithanda nako konke lokukhuluma kakhulu engikwentako nyalo phela mina ngiyakhuluma ngimuntu wasitfotsa lokhulumako because if I'm going to show direction, I must talk about all things. Yes, I'm not always right. Yes, I'm sometimes very wrong. Yes, it's ugly. Schwa. Yeah. Alright guys, so how do we get about 5 marks there? Formulas, descalculase, descalculase, the answer provided we've got the correct unit times the correct formula, SI unit, and the direction. Wow, I forgot the direction. This is a vector. You. That last mark without the direction, you are dead. This is just another way of presenting the answer. Let me put it there as an interference. So newtons per coulomb. In which direction, guys? To the right. Yes. Because it came out positive, to the right. Sometimes you may just use an arrow to indicate that. Or you can even say towards charge Q. Towards charge B. Someone may say, or towards QB. That is also acceptable. So remember, the answer, guys, is for all these three. If any one of them is missing, the last mark is gone down the drain. Okay, guys. So that was it for these 18 marks. And for this total of 150 marks, but we saw that they were not exactly 150, right? Yeah, there were some questions that are questionable in how those marks came about, and it looks as if there was some errors somewhere as well. Either way, guys, wrong or right, what we have done is just a necessary exercise to give you a perspective in preparing for a physics paper 1. Of course, by the time this premieres, it's going to be the next day than the day in which this was done. Please, guys, watch the video and enjoy. I will also prepare a full paper this time, perhaps that you guys can watch on Thursdays during the day. I'll try to make sure it premieres on Thursday early so that you can have it for the entire afternoon. I'll try to be as precise and precinct as possible for that one. This one was just to build a nice knowledge base for you guys to remember what is important. Of course, there's plenty other videos in the channel if you need more. Yeah, then we will meet essentially in the evening at 7 to do a one-on-one, or is it many on one? Yeah, this function that we are is many to one or one to many. So yeah, and what type of a function is one to many? We are parabolic. Yeah, we do pass the vertical line test. We are truly a function, but the inverse doesn't work. It's not a function. Anyway, guys, I hope you enjoyed the video. Give it a thumbs up just for the sake of others, if not for me, for the hard work that I do for you guys. Besides, there's not very much I personally benefit, but it's just called giving back. I'll see you guys next time. Goodbye.